Welcome to Villa Vigoni again. As you know, we are a unique binational Italo-German institution, so you'll work in English, but we have a nice tradition to use both languages, Italian and German. We also try to encourage guests to use Italian and German as scientific languages, which can still happen partially in the humanities and social sciences. And so I'll welcome you in both languages, and then we'll work in English as planned, and I'll start with my foreign language, that is German. Also nochmal herzlich willkommen in der Villa Vigoni. Mein Name ist Francesca Ziglio. Ich bin stellvertretende Leiterin der Abteilung Forschung und Projekte hier in der Villa. Nuovamente benvenuti a tutti, mi chiamo Francesca Ziglio, sono la vice direttrice del Dipartimento Ricerca e Progetti qui a Villa Vigoni. Obwohl die meisten von Ihnen für das erste Mal hier sind, sind heute mehrere Institutionen vertreten, mit denen Villa Vigoni eine enge Beziehung hat. Zuerst natürlich SIGN, das ich sehr gerne in der Villa eingeladen habe, mit dem wir zusammen dieses Treffen organisiert haben, und wir hoffen auch, dass es nur das erste Treffen ist von einer Reihe in der Zukunft. Die italienische Botschaft in Berlin, die deutsche Botschaft in Rom sollte auch vertreten sein. Die Vizekonsulin in Mailand war leider krank, aber sie hofft, dass sie später zumindest von remote dabei sein kann. Consiglio Nazionale delle Ricerche, das wie beide Botschaften zu unserem Gremium gehört und das mit uns zusammenarbeitet. Zurzeit haben wir auch 2 trilaterale Forschungskonferenzen, die von italienischerseits von Forscherinnen des Consiglio Nazionale delle Ricerche geleitet sind. Und letztlich haben wir auch Mitglieder der Villa Vigoni hier zwischen uns, im Moment nur 2, aber vielleicht wird auch jemand von Ihnen in der Zukunft Interesse haben, Mitglied der Villa Vigoni zu werden. Na, ich bin Mitarbeiterin, aber wir sind eine private Assoziation, und das heißt, wir haben Mitglieder. Sandro Moraldo ist ein Mitglied und Chiara Franceschini auch. Dunque, come dicevo, la maggioranza di voi non è ancora qui per la prima volta, però oggi sono rappresentate una serie di istituzioni con cui Villa Vigoni ha dei rapporti molto stretti. Innanzitutto SIGN, con cui ovviamente abbiamo coorganizzato questo evento e che speriamo possa tornare anche in futuro a Villa Vigoni con una serie di appuntamenti stabili, l'ambasciata d'Italia a Berlino, l'ambasciata di Germania a Roma, che avrebbe dovuto essere rappresentata dalla viceconsole a Milano, che ha avuto un problema medico ma spera di riuscire a collegarsi da remoto più tardi, il CNR, che è membro del nostro consiglio direttivo insieme alle ambasciate con cui collaboriamo, e abbiamo al momento anche 2 ricercatori del CNR che sono i responsabili per parte italiana di 2 progetti di ricerca trilaterali che finanziamo appunto attraverso il nostro bando italo-franco-tedesco, che in questo momento sono 2 archeologi, ma abbiamo avuto anche ricerche trilaterali su altri temi. Abbiamo anche dei soci privati. Villa Vigoni è un'associazione di diritto privato e quindi ha dei soci istituzionali e dei soci privati, per il momento solo 2, ma magari in futuro ci sarà qualcun altro di voi che sarà interessato ad associarsi. Quindi credo che questo nostro incontro rappresenti bene il network italo-tedesco di Villa Vigoni e anche le opportunità di incontro e di scambio che Villa Vigoni offre al mondo italo-tedesco in ambito accademico, ma non solo. Hier sind, wie gesagt, mehrere Institutionen und auch Mitglieder des Vereins gesammelt. Und ich glaube, dass deshalb dieses Treffen die Möglichkeiten zeigt, dass man in Italien und Deutschland durch die Villa Vigoni App sich zu treffen, zusammenzuarbeiten. Natürlich kommen viele Akademikerinnen hier in der Villa, aber auch außerhalb der Universitäten und Forschungseinrichtungen gibt es weitere Möglichkeiten zum deutsch-italienischen Austausch hier in der Villa Vigoni. Wie Sie wissen vielleicht, oder zumindest einigen von Ihnen wissen, haben wir heute ein Thema, das für die Villa eher eine Ausnahme ist, weil die Aktivitäten, die von uns organisiert und finanziert werden, sich normalerweise im Rahmen der sozialen und Geistwissenschaften befinden. Also die Villa ist auch für alle möglichen Bereiche offen, aber das, was wir organisieren und wo wir auch Kompetenzen haben, sind die Geistes- und Sozialwissenschaften. Aber wir haben ein Programm entwickelt, VigoniRicerca, das genau gedacht ist, um Forschungen und Forscherinnen zusammenzubringen, die über Themen arbeiten, die sowohl die sozialen und Geisteswissenschaften als auch die Art Sciences betreffen. Und ich denke, obwohl es sich um eine Ausnahme handelt, denke ich, dass dieses Treffen ganz gut zu unserer Mission und auch zu der Geschichte dieses Ortes passt. Und ich werde sehr kurz etwas über diese Geschichte erzählen. Il tema di questo nostro incontro rappresenta da un lato un'eccezione alla regola, perché gli eventi che sono finanziati e organizzati dal nostro Dipartimento all'interno riguardano le scienze umane e sociali. Questo è l'ambito in cui lavoriamo e in cui abbiamo anche competenze interne, mentre la Villa è completamente aperta a qualsiasi altra materia per studiosi e non solo che vogliano incontrarsi qui, ma non essendoci competenze interne noi non organizziamo eventi o pubblicazioni in queste materie. Tuttavia abbiamo pensato di avviare un programma che si chiama VigoniRicerca, che è proprio destinato a dare l'occasione di incontrarsi e di discutere a studiosi e a ricercatori italiani e tedeschi che si occupano di temi che stanno proprio a cavallo fra le scienze umane e sociali e le scienze dure. E nonostante questa rappresenti un po' un'eccezione per i nostri standard, io credo che l'incontro di oggi e il programma in cui si inserisce rispondano bene non solo alla missione della nostra istituzione, ma proprio anche alla storia di questo luogo che voglio brevemente raccontarvi. Wir sind eine ziemlich junge Institution, noch in 86 geboren. Warum befindet sich eine solche Institution hier am Comansee? Weil der letzte Besitzer, Herr Ignazio Vigoni, der in 1983 gestorben ist, sich dafür entschied, die ganze Liegenschaft hier als Erbe der Bundesrepublik Deutschland zu geben, mit einer Kondition, und zwar, dass eine binationale kulturelle Institution hier gegründet wird. Und daher ist das Verein Villa Vigoni entstanden, das ein privates Verein ist, aber meistens von beiden Ministerien, das italienische Ministerium für Auswärtige Angelegenheiten und das deutsche Ministerium für Bildung und Forschung, finanziert wird. Succede spesso che qualcuno si chieda come mai un'istituzione del genere, un'istituzione binazionale, si trova sul lago di Como, in un luogo piuttosto piccolo, non in una grande città, e questo è successo perché l'ultimo proprietario di Villa Vigoni, Ignazio Vigoni, nel 1983 decise di lasciare in eredità tutta la proprietà alla Repubblica Federale. Quindi questa villa in cui siamo, l'altra villa in cui si svolgono i lavori, vari edifici adiacenti in cui dormite, la Darsena giù all'imbarcadero e tutti i giardini e il parco, e la lasciò in eredità con la condizione che qui si costruisse un'istituzione culturale binazionale, che è appunto nata nel 1986 e che è un'associazione di diritto privato registrata in entrambi i paesi, ma è prevalentemente finanziata da fondi pubblici, in particolare dal Ministero degli Esteri per quanto riguarda l'Italia e dal Ministero dell'Università e della Ricerca per quanto riguarda la Germania. Warum hat Herr Vigoni so eine Entscheidung gemacht, die sicherlich unerwartet war? Er hatte nichts davon gesagt, es war auch für die Bundesrepublik eine Überraschung. Die Idee war, dass er das Gedanken und von Heinrich Milius, er war der letzte dieser Milius-Familie. Er wollte das Gedanken vorantreiben und auch alles, was er für die deutsch-italienische Beziehungen gemacht hatte. Herr Milius war ungefähr vor 250 Jahren geboren in Frankfurt am Main. Er kam nach Mailand als Geschäftsgründer für die Familienindustrie. Er war mit einer Dame aus dem Weimarer Hof verheiratet und auch durch sie hatte er sehr enge Beziehungen zur deutschen kulturellen Welt der Zeit. Er war in Mailand wirtschaftlich extrem erfolgreich und entschied sich dafür, mit diesem Vermögen viel für die Kultur, die Kunst und die Bildung in Mailand und nicht nur in Mailand zu tun. Ignazio Vigoni era l'ultimo erede della famiglia Milius, in particolare di Heinrich Milius, che fu il primo abitante di questa villa come la vedete adesso, che era un uomo di affari che nato circa 250 anni fa, si trasferì da Francoforte sul Meno a Milano per motivi di affari, per rappresentare l'azienda di famiglia. Ebbe un grande successo economico e decise di dedicare buona parte del suo patrimonio ad attività che riguardavano la cultura, l'arte e l'istruzione intesa in senso molto ampio, dagli asili fino alle scuole di formazione tecnica, e attraverso il matrimonio con una dama della corte di Weimar ebbe anche dei contatti molto stretti con i massimi rappresentanti della cultura tedesca dell'epoca, che utilizzò per appunto creare dei forti legami fra l'Italia e la Germania in ambito anche culturale, non solo economico-finanziario, che era il suo lavoro, e anche in ambito politico. Vi farò solo due esempi che secondo me danno un'idea del perché questo nostro incontro è legato anche alla storia del luogo in cui ci troviamo. Heinrich Milius fece conoscere Manzoni e Goethe, e questo è il motivo per cui I Promessi Sposi furono tradotti molto velocemente in tedesco, addirittura in 2 edizioni, nonostante all'epoca la tradizione fosse quella di fare la prima edizione internazionale dei romanzi in lingua francese. Ma Milius fondò anche la SIAM, Società Italiana Arti e Mestieri, che tuttora esiste a Milano, e alcuni professori attivi nella SIAM furono poi i fondatori del Politecnico di Milano. Quindi abbiamo anche questo legame con la formazione tecnica di alto livello, anche se magari non sarebbe la prima cosa a cui si pensa quando si entra in una villa con quadri di Hayez, etc. Nur zwei Beispielen der Aktivität von Heinrich Milius in Mailand zeigen meiner Meinung nach, dass unser Treffen heute wirklich auch zu der Geschichte dieses Ortes passt. Heinrich Milius hatte, wie gesagt, sehr enge Beziehungen mit der kulturellen Welt, sowohl in Italien als auch in Deutschland, und er war derjenige, der Goethe zusammen mit Manzoni in Kontakt gebracht hat, und deshalb hatten die Promessi Sposi das wichtigste Werk von Manzoni, das hier am Comasee spielt, sehr schnell zwei Übersetzungen ins deutsche Sprache. Milius war auch in der Bildung und auch der technischen Bildung sehr aktiv und gründete die SIAM, eine Ausbildungseinrichtung für Gewerkschaften, die noch existiert in Mailand. Und in dieser Einrichtung versammelten sich Professoren, die später das Politecnico di Milano, also die wichtigste technische Universität in Italien, gründen. Deshalb haben wir auch mit der technischen Bildung einen Zusammenhang, obwohl man hier in der Villa nicht sofort ahnen würde, weil wir natürlich Bilder, Möbel, Bücher, ganz viel haben, das die kulturelle Beziehungen zwischen beiden Ländern zeigt, aber wir haben auch dieses wichtiges Thema, und auch deshalb freue ich mich besonders, dass Sie hier sind, hoffe, dass dieses Treffen nur das erste von einer Reihe ist, und wünsche Ihnen eine gute Arbeit.
I would really break any tradition and speak next to the slides, like now. Mic on. Very good. Okay, great. So welcome here. Sorry, can you hear?
Yes.
Yeah, very good. So first of all, the language is okay with English, or you prefer German, my German, or Italian? Okay, so English. Let's take with English. Very good. Great. So first of all, we are very, very grateful to Villa Vigoni, and Francesca was a little bit understated in telling all the story. She's really the responsible person that we can gather here today, because when we founded SIGN, she approached us. I should admit I didn't know about Villa Vigoni, or I should have known, but once I Googled it, I say, wow, that's the place for us, because SIGN, this association that I would like to pitch to you, is not an association of chemists, physicists, or engineers, although probably the genesis is very much related to people coming from these disciplines, but wants to be really a roof for all research activities done in Germany by Italian or Italian-related people. Can be a guy who coming from Iraq who did a PhD in La Sapienza and then coming to Germany, and probably with an overambitious goal to be the same for the little, not so as large like in Germany, presence of German scientists in Italy. And with this spirit we started. And let me tell you a few things, which starts with a pitch. So what is the pitch for SIGN? SIGN is this nice fantasy name that also our ambassador Baricchio was contributing to forge, but it should be really an association of scientists with Italy and the Germany relation. But the real pitch are the numbers. And let me just go through the numbers. So the number of students Italian students studying currently in Germany is not the first group. I mean, there are a lot of Chinese, Indian, we know this, but given our size is huge. It's 15,000 students. 50. Oh, no, you can hear, I guess, right? No. 15,000 students. 15,000 students, Italian students. It means a university as large as the University of Regensburg. Only the presence. Then, sorry, let me first go through the PhD. Of the Italian PhD population, Italian students doing a PhD, 24% of them are doing this abroad. And this might sound reasonable in a time of really exchange of science, but if we look at the numbers, the average for the EU is 7%. The average for France and Germany is 4%. So if we think about Italy and Germany, we see that we start seeing a big asymmetry. And now the asymmetry is also coming here. There are currently 300 professors at German universities. A couple of them are sitting here. And we are the first non-German speaking group, so non-Swiss and non-Austrian. This group is 10% of the professors in Germany. So in times of quote of minorities, etc., I mean, we need to voice up our presence. Well, I don't know if we need, but there might be if you want, the political idea to have really a group, because 10% is over 5%. And 5% in statistics, we like to say, is something that is over a significance level. And more or less are 5,000 scientists currently employed at German university and research institutes. At let's say, German university, almost 4,000, and more than 1,000 with the Max Planck, Fraunhofer, you name them. So this is the pitch. There is a strong presence, a strong asymmetry, and we want to do something. And this is what we were discussing with the ambassador. Sorry for this picture that I was receiving, because of the one that embassy sent to us. And eventually, out of this discussion, we came with the signing of this foundation document with the fiduciary notary of the embassy. And we thought, okay, great, we are a charity foundation. Haha, we thought. Actually, in Germany, the non-profit stamp is coming only when the Finanzamt is telling that this is okay, and Vincenzo and myself are really heavily fighting for that. We are not yet existing as a charity. That's why we are not yet enlarged the number of founding members. The institutional backup is there. The embassy is the seat of the association, the embassy in Germany. Professor Carrozza, the already minister of the MUR, already president of Sant'Anna, and now president of CNR, came to Berlin to the Foundation Act. But actually, what we are and what we want to do is written a little bit here in the mission. So we want to recognize, foster, and celebrate science, Italian presence in science in Germany, giving prizes, giving little scholarships, I mean, depending on the budget that we have. Give back expertise and best practice. Some of us are consulting also Italian institution or governmental structure. And if we are clustered, we have a better outreach in this direction. And then really, there is a big issue with the brain drain in Italy that I don't think is an issue that Italian people are living. The real problem that the difference, so we don't have enough brains from outside Italy coming to Italy, so this brain drain minus brain gain is unfortunately still too positive, or negative if we do the opposite, of course. And by doing this, you all know the association. Please spread the news among your PhD students, postdoc, and even students. If you are undergrad, you basically is an association for free, because we really need to have a network scale effect. And I think QR code is also in our booklet. And actually, the power of this network is the network. And that's the first picture that the embassy was sending me with the part of the founding members here at 12th of October in Berlin. I say part because a good 20 extra colleagues, Vincenzo, right, are sent the procura, so they became founding members without having the possibility to come to Berlin. And at this point, I would like to point out someone that tends to stay not in the first row, and I would like for Vincenzo to Francesca to call for a special applause, because whatever you see here would not be possible without the strong engagement of them. This journey started with Vincenzo Dovi, with Matteo Pardo, former attaché, scientific attaché at the embassy, and is currently going on with Vincenzo. We know how the logic of diplomacy sometimes are not really aligned and correlated with the logic of, I would say, common sense, but let's say what we are typically to do at our university, and we know that things we need shoulders, and the shoulders of this association are Vincenzo, and of course, so the power is the network, and we want really to scale and to have really a lot of ideas coming. We had already many of the people sitting here massively contributed to be what we are. And we are here today for our first non-embassy-like type of meeting. I mean, embassy-like, I mean, coming there, having a roundtable discussion with big shots and telling a lot of things with a Sole 24 journalist interviewing people. But come on, we are scientists and we love to discuss about science. This is the first meeting. And I'm particularly thankful to Villa Vigoni and Francesca, who made the catalysis, because we heard that Villa Vigoni is prominently humanities and social sciences. And SIGN is not only humanities and social science, but we want really to find every year possible titles, possible roofs, which really accommodate all people that are active in science. And AI, which is the kickoff meeting of today, is super predestined to do this, but art would be the same. I mean, I'm not sure that a person in hard science might like, oh, you come here in a villa full of nice painting, you will not think that is something for engineers. Actually, we should go back to times in which the cultures are coming again together. Probably some of you know this Snow type of pamphlet about the two cultures. Probably SIGN is also giving a contribution to bring humanities and what we call hard science, means STEM science together. And we do this again with the strong support of Villa Vigoni, with an amazing program, very much synthesized in you, speakers sitting there, coming here with a microphone, whatever. And we are really eager to listen of your contribution. If you like your contribution aligned with the audio from the microphone, can be put in our and in Villa Vigoni's YouTube channel with your, of course, approval. And I strongly recommend that you like to approve this, because it's also giving visibility from what we are doing and, of course, to your research activity. I broke a little bit the program in this not very ordered way, just to point out something that we typically forget at the gathering and symposia, to have a group picture. So please put in your telephone an alarm clock at 4:29. So it will be a good reminder for the last speaker, poor Giuseppe, to finish. And remember that before actually going to the coffee break, Francesca will tell us what is the best spot for a nice group picture. Okay? After having said that, we are here, and we wish all of us an amazing first symposium of SIGN. Thank you. let me tell you what I know. We studied together in Geneva with the delta of 1 year. Then he joined SIGN with a lot of amazing pioneering work on machine learning and sensory. And then he joined the embassy in Berlin as a scientific attaché. And after that, he's still with the CNR in Berlin, so you can tell us about something that I think we can say is already official. Matteo is the driving force, the general secretary, I guess, of the Italian act. So we all know the Lincei, or the pure science, and like the in Germany. But we have also since a couple of months an academy of engineering, like the US, like Germany, and we're very proud that we are the driving force there. It is aligned with the Lincei, so let's hope that the average age will not be the same as the one of the Lincei. Men will only be allowed after the third constant operation and things like that. But I mean, it's an amazing central figure in Berlin, and so Matteo, we are sharing and
Okay. Okay. Thank you very much for the words, too kind. And so before starting the session, I would just tell you something which is not in the program. We are signing today after lunch, most probably, an agreement between CNR and the FKI. It's a general purpose agreement, obviously centered on artificial intelligence. It has been signed by our President Carrozza a few days ago in Rome. It has been brought here by Giovanni Felici with his own hands, and I still didn't see it, but and Antonio will sign it so after lunch, and we will have a photo with let's say the few CNR and Antonio representing the FKI obviously, and then we will make the group photo. That's the idea. If we have various possibilities to make it outside, inside. Okay, since I mentioned Antonio, who will open this conference, let me tell you that part of the organization came out of a series of webinars on AI, let's say co-organized by me and Vincenzo Fiorentini, and this seminar series had 5 seminars, German, Italian. The Italian part was from CNR or associated with CNR, and the German parts was at the end mainly the FKI, but with exceptions. So actually, Wojciech, Antonio, where is it? Giuseppe, and at least another person. I don't see it right now, but I think there were 4 came out of this webinar series. That it was nice to co-organize this webinar series together with this workshop here. Okay, having said that, let me introduce the speakers. The house rules are that the speakers have half an hour, more or less, and then there will be 15 minutes to discuss what they just spoke about. Okay, so it's 45 plus 45 is 1.5 hours for each session. And so without further ado, let me introduce the first speaker, which is Antonio Krüger. He is CEO and scientific director of the German Research Center for Artificial Intelligence. And there he heads one of the departments, which is called Cognitive Assistance. As always the case for high-ranking persons from research institutions, he has a double appointment. He's also a full professor for computer science at the Saarland University in the state of Saarland in Germany. And I mean, he has a lot of things to say. He was a professor of computer science and geoinformatics at the University of Münster before coming to Saarbrücken, and was acted as a managing director of the Institute for Geoinformatics there. He studied computer science and economics, I read, at the Saarland University, and obtained a PhD in 1999, actually as me, as a member of the Saarbrücken Graduate School of Cognitive Science. He published an amazing number of papers. Oh, okay, so I will introduce also the speaker after you so that we have it in a go. And the second speaker is Anna Maria De Cesare from TU Dresden, from the Technical University of Dresden. And she is in the spirit of having the hard science and the soft science or humanities together. She holds a PhD in general linguistics from the University of Geneva, and she is the chair of Romance linguistics, French, Italian, at the TU Dresden. So also the technical universities in Germany have this characteristics of having the bulk, I would say, in Berlin at least, it's like that, dedicated to the hard sciences, but a component also which is not hard science. And she will speak herself of her domain of expertise. Importantly to us is that she's currently developing a new research field in linguistics centered on the study of AI-generated texts in Romance languages. And she will present that today. She will talk about challenges of AI text generation, thoughts from the field of Romance linguistics. But first, let's hear Antonio.
So, yeah, as much as I like also to stand up and talk, you know, I was a little bit put off of carrying this thing around, you know. Although you did a great job, I think, you know, it looked perfectly okay, but I think I'll try this now. And then the subsequent speakers can decide, you know, which slide is maybe nicer. So, thank you very much for the nice introduction. I have to say it's really a pleasure and also an honor to be here in this very nice place, you know. Of course, I was not aware that it existed, you know, as a computer scientist, yeah. But I'm glad that I know now, and I'm also very much honored that I have the possibility to open up actually the scientific track. Yeah, we'll talk about it later. So I see there's much I have still to learn about this. It's very good actually. And of course, you know, you have placed me in a room that is named after Antonio Kramer, which is also very interesting, a chemist who obviously lived in the 19th century, you know, also German-Italian connection there. And of course, as you see from my name, you know, there is, of course, a perfect match here, you know. So I'm also have a very personal attachment also to be here, and I'm very grateful to have the possibility to speak to you. So while my presentation which has 1.2 gigabytes, it's always a problem with computer scientists, they completely ignore the data size of the files, you know, and already took 20 minutes to download it. 2 words about my different hats. You mentioned this, you know, I have an education which is a computer scientist education, but it has been early on pretty interdisciplinary because I was in this cognitive science program. There are psychologists in that program. My co-supervisor of my PhD is a psychologist, for example, and my research interest is very much focused actually on this boundary of natural and artificial intelligence. You know, while I'm through all kind of strange paths, you know, that were not foreseeable, I ended up in a management position, of course, you know, at being DFKI's head. DFKI has more than 600 researchers. We have 8 offices actually spread across Germany in 6 Bundesländern. And but of course, I have still this head of a researcher, and I've decided deliberately actually to put that hat a little bit on. You know, I'm still doing a little bit of research, you know. Giovanni knows this, you know, we have a history regarding the ESC grants, the starting grants, you know, Giovanni organized the panel, and I was part of for several years. So, so I will talk about cognitive assistance in intelligent environments, and talk a little bit briefly about the research we're doing there. I'm trying to stay on a high level. I know there are many different disciplines present, so I will not delve into too much technical details, I hope, you know. So yeah, you know, at least that's my goal. So those are the PhD students and postdocs that contributed actually to this research. And later on tomorrow, Vanshika will talk about a different strand about chatbots in the museum. We have DFKI is mostly project organized, so all of the research is done in projects, and currently there are roughly at any moment in time 400 projects running in all the various research departments at DFKI. So this is only a very subjective subset, you know, of the research we're doing. DFKI, we do all kind of, we cover all topics of AI, basically, from robotics, natural language processing, vision, of course. And actually my field is this kind of human in the loop, you would say. This would be maybe the more modern approach to it. Here you see kind of an overview. It's interesting that's a little bit tilted to the northwest and not to the southwest. This has to do something. This is not pure chance, you know. This is mainly because DFKI is present where no other AI competence centers in Germany are present. So that's one reason in the Bundesländer. So if you look at the AI competence centers, then you will see it's more kind of a southwest skew. You know, from Dresden has one, Munich has one, Tübingen has one, Dortmund has one, Berlin has one. There's an overlap actually. That's the only Bundesland where we are present and also a competence center. But actually it's a network and we are intertrained, but this is, I could speak, you know, at least half an hour about this, but it's too boring actually. DFKI has a very practical approach to research. So one of the main missions is actually taking a result from basic research that of course we do basically in our chairs at the universities. Currently we have 28 directors at DFKI spread across those locations, and they all have their specific topics. They all have their chairs, as Matteo mentioned, this double position, and basic research is mainly done there, also at DFKI, but DFKI's main mission is actually transfer. This is done in many different areas, for example, in retail, automotive, of course, important for German, robotics, a lot in production. So the term Industry 4.0, I don't know who has heard about it. This is something that has been coined actually at DFKI 15 years or 10 years ago. So this is basically a little bit the approach. We usually have kind of certain scenarios in mind, also real world problems that we want to address, and then we try to transfer solutions, you know, and then gain by this again insights for research back. So I would like to talk about where we are moving, yeah, and one, you know, with all these AI models that are around, you know, of course, the notion of autonomy, and I'm now speaking not about from a human-centered perspective, but from a machine-centered perspective, autonomy. So that means we can, if we assume that more and more tasks are done by machines, even tasks that maybe at the moment we don't believe that they will be carried out by machines, but obviously, you know, we are kind of, the boundary is moving. Then the question is, what will be the role of the human actually in this kind of systems, of kind of complex autonomous systems? And the question is, will this be more something like this, you know? So from more direct control, more to supervision, like air traffic control, for example. That's a complex system. There's humans in the loop. So you have kind of all the other control rooms, you know, or similar rooms can be found more and more also in other areas, for example, in power networks, in intelligent city management, and so on. So is this moving more to type of supervision and not so much direct control? So that's one question. The other question is, if we move to supervision, you know, what happens actually to the skills that we need in case that something goes wrong? You know, this is again something. So I remember a talk from a Google engineer 7, 8 years ago, tech talk, where he basically was super convinced that his children that at that time were kind of aged 14, 15, that they would not have to take a driver license test anymore, you know? So the question is, this of course was a little bit a wrong assumption, you know. There are many scientific forecasts that turn to be a little bit, you know, too optimistic, yeah. But still, you know, the question is, if you look at pilots, you know, they basically, most parts of the journey are carried out by the plane autonomously, yeah. But still, you know, we have a pilot fortunately, currently there's Airbus, for example, is trying to get rid of the second pilot, of the co-pilot. So having only one pilot and this turns to be out not easy. That's not an easy task to get the routines, the mechanisms in a way that you can comply with all safety regulations and so on. So, and of course, safety regulations is always also a debate in society. What kind of risks are you expect to take, and what's the balance in the end? So the question is, do we have to, for the complex things, have more rely on simulation and work on simulation? So in case that something goes wrong, somebody can jump in, for example, when while driving. The other thing is, of course, that the virtual and the real environment are kind of merging. I think this is something, it seems a little bit distant here in this very nice place, which has a very physical presence, but of course, this is also an observation that one can make, has made, in the last couple of years, that these things move together. We get more and more kind of virtual environments that are pretty convincing. We have metaverse. I'm not using the term. I like the term because of the book, but I don't like it in the way how Meta is using it. But anyway, there is something to it, the way what these kind of virtual environment play in the role of controlling, supervising the mixed digital and real world. In the end, if you come from the human perspective, it's pretty straightforward. Humans are very complex organisms, of course, complex machines, but in the heart, they rely on a perception action loop. So, of course, this is very kind of abstract, but it's important to understand later on if you try to connect, put humans into control of a mixed environment. So we have senses, we have actions. In principle, if you would have the perfect digital environment, you could simulate this, like in the movie The Matrix. I don't know who has seen this, but where you would perfectly simulate all these senses, and you would record the actions and so on. Then the reality wouldn't be distinguishable from the digital world. We are far away from this. It's unclear whether this will happen, but it's good to understand that through all these channels, currently the fidelity is very different. So vision is already pretty good. The audio channel can be manipulated pretty good. But already when it comes to haptics, it's getting difficult. You have currently state of the art kind of vibrating controllers. This is not how the real world works. So this is when it then comes to smell and taste, which are very complex senses, then we are completely off. Basically, there are no good approaches to manipulate actually that part. Then regarding the action loop, we have the muscles. We have certain way to measure muscle activities. We have certain ways to activate muscles, for example, by the digital world. But there's still, on the right-hand side, there's lots of open field for research. On the left-hand side, we are more in the consolidated space. We're pretty far. This is called the virtuality continuum. I will go quickly through this. So on the one side of the virtuality continuum, you have the real environment. On the other, you have the virtual environment. And that's why, we talk about mixed reality when it's somewhere in between. I think this is maybe something you're already familiar, And moving this from the left to the right is an interesting way how to manipulate how we perceive something, how we can control something, And it's currently, although the concept is already pretty old, old in terms of computer scientists, of course, for the humanities, this is all super young field, of course. I know. So you have augmented reality there, then you have augmented virtuality, which is a complementary concept there, and mixed realities in the middle. And when you connect actually virtual environment to the real world, and you can do this by sensing, then you can create pretty compelling experiences. This, for example, is a virtual climb. I've shown this game before, The Climb, which is a virtual climbing game in virtual reality. This is very similar, but this is with full haptic feedback because you're really climbing on a treadmill. You can see this here on the right, and your feet and hands are fully tracked and synchronized. So the system knows exactly where your hand and feet are. And so when you grab a virtual hold, you grab a real hold, And since it's a treadmill, you can run there forever, But in the virtual environment, of course, you can climb, up. So this is a treadmill, basically. So, And of course, the holds repeat. But this again, you know, it's an interesting, again, an interesting question, you know. So what you feel and what you see, you know, you can merge those impressions. So you can show different types of holds, you know, for this. So whenever people have to get off the wall, that's actually the fearless exit. It's very hard because they're very high actually, and they have this height perception. So what we do is you have to introduce a virtual platform, you know, of the real ground, so people are confident to step off actually the wall. So this is something you can do. Then of course you can combine this with cultural heritage now. Those are examples now. And this is HoloLens 2, that's actually state of the art at the moment. Let's see how the Vision Pro from Apple will basically perform. This might be even better, yeah, I guess. But already with that technology, you can provide pretty compelling visualization, you know, of historical buildings, of things that are not there anymore. You know, you can go through them. So it's already advanced, actually. Yeah? And again, so combining digital and real does not only work for the present, but of course for the whole line of the past. And of course, if you think about planning and so on in the future also. Yeah? So you detach yourself a little bit from time as well. Yeah? So another, I think, interesting observation is that computing technology is moving towards the human body. Often people say it's moving into the environment. This is also true, but it's also, since humans are part of the environment, it's in particular also moving towards the human body. So it started actually with desktop PCs and mobile phones in your pocket, then smartwatches and sensors on the body. All kind of different sensors now can be in principle attached to the body and measure physiological functions and can also manipulate actually the body. This is also, if you think about the perception action loop, you know, so you can also manipulate the body. And this, and we will see more and more of that. Again, I think it's also a societal debate whether how far you want to go here, whether you want implants and so on, you know, the chips that maybe, I don't really believe in it, but at least not in my lifetime, but that might augment actually your cognitive functions directly. Not sure. So one example, which might look a little bit scary, but I think it's an interesting, is something we've did is the foot striker. That's actually a device that helps you to learn a new running style. So usually when you run, so beginners, when they start to run, and most of us, they basically use a heel strike. That means you get your foot down through the heel, and then you go over the whole single foot, and then you get off. There is actually this forefoot running style where you basically land on your forefoot and you propel yourself. This is a little bit different. People usually, if they want to change the running style, it's quite a tedious exercise to do this. You have to remind yourself you're getting back into bad habits. What you can do is actually you can use sensing technique, machine learning, and muscle actuation to force people into force, in a way, your people into a forefoot position at the right moment in time, you know. So this is actually what you see here is a kind of a muscle stimulation device that activates the calf muscles. And in this little box, you have actually a little bit of sensor machinery. You have a small algorithm running that basically determines where your foot is actually, in which position. And then shortly before landing, it basically activates your calf muscles, and this brings your forefoot down, and then you land on your forefoot. What's very interesting here is that this is a mechanism that is not really noticeable. It does fizzle a little bit on your calf. It's not, but it's not like that you get a cramp or so. It's really a fizzle. And and of course in the studies that we did with participants and so on, half of them could not tell what was going to happen. They were running on their forefoot. Yeah. What's very interesting from a cognitive perspective is that although we did this only on one leg, you know, it transferred to the other immediately. So there is a kind of a transfer effect, you know, in our brain from the symmetry of our movements and so on. And that's a very interesting way how to shape through muscle activation also your cognitive actually abilities, because in the end running is a cognitive ability, you know, it's kind of steered by our brain, you know, also the running style and so on, and this shows kind of this line, you know, where you have a machine, a mechanism, you know, that it kind of extends certain functions of our body and our brain. Yeah. So it's different. So there is a little bit of a debate, but many actually, in particular, marathon runners run forefoot, but it requires also very good ligaments, you know, and muscles and so on, because you have to damp. Actually, you're not damping through the shoe, which most shoe to the soil, but more through your muscle and ligament system. So what's interesting again, if we extend this. If you're interested, you know, you can come to Saarbrücken and try it, you know, it's no problem. You will not be electrocuted, you know, this is for sure. It's all medical grade devices. So you can bring this further. This is again, you know, very interesting to see how can physiological factors actually influence the way how we interact with machine, with this kind of cosmos. For example, if we use EEG, so actually you measure your brain activity. What you can do is, for example, in machine learning tasks, when you try to teach a machine something, so this part of machine learning, you know, a robot, for example, you by demonstration, by explanation, for example, then what you can do is, for example, you can measure the user's brain activity that is monitoring the robot, and whenever the robot is not getting the instruction or doing something in a wrong way, this can be detected through what's called error-related potential. That's one of the, I would say, well-working effects in EEG. There are many effects that won't work very well because you get this kind of projection, you know, of what's really going on in your brain through the cap and so on, you know. But the error-related potentials is something that's easily detectable. It usually is associated with something that goes wrong in the environment of the human. And what's interesting here is that, of course, we can measure this. Basically, in the same moment, the human is noticing that something is wrong, and we can give this feedback directly to the robot, so the human has to say nothing, you know. And the robot, if it has a second good hypothesis, you know, that is strong enough, can just start to do that, you know, instead of waiting, of being corrected, and so on, you know. So again, here we use the perceptual capabilities of the human and the human brain in combination with a machine learning device. Again, this is a very interesting field of research, and we have several groups at DFKI that look at it because we have this possibility. One, we have BCI labs, so brain-computer interaction labs, several actually, and we have very strong robotics, and we put these two things together. Yeah, and this actually brings actually a couple of interesting research questions. One is related to this kind of transfer of control and who's in control and when. Yeah, so and how do we move control from one side to the other? And the other one is how to combine actually how to use actually a virtuality continuum to execute control as a human and to be able to control this kind of mixed digital and real world. And I will talk a little bit about this. So this slide is already a couple of years old. Actually, this part here, this thing has been inspired by Eric Horowitz. He's actually a principal researcher at Microsoft. He gave a talk in 2015 about a collaboration in hybrid teams in where you have humans, where you have machines, maybe robots in a collaborative robot setting, maybe soft bots, so some sort of cognitive tool. Yeah, I don't know. Yeah. And he talked a little bit about at that time what humans are good at, what machines are good at, and how maybe to combine those. Now with large language models, I think this this discussion has been stirred up again in a much stronger way, and maybe a little bit in a different way than people expected. Because for a long time, what we thought actually was that humans, that actually machines were not very good at kind of procedural knowledge, you know, and processing procedural knowledge, like riding a bike, like, I don't know, juggling, like doing sports and so on. And now it turns out, and I think this is still true to a certain aspect, but now it turns out that many things that we associate with deep cognitive processes turns out to be also procedural in a way. Yeah? So, and that's what the large language models do, basically, you know. And people also now compare this to Kahneman's slow and fast thinking systems. And it turns out that all these things, you know, that, and I also strongly believe in it. I think it's a very good comparison and a very good analysis, actually, that the language models, the foundational models, they are basically fast thinkers, you know. And what does it mean for our own capability? It means that many of our behavior, you know, that we might associate with deep thinking, so talking and so on, is in fact, fast thinking, you know. So, and this is pretty interesting, because this means we can have very strong support that actually the domain of fast thinking is much larger maybe than we thought, you know. So giving this talk relies very little actually on slow thinking. This is, most of it is fast thinking. And so we can get lots of support in fast thinking. So I could imagine that, you know, in maybe 10, 15 years, you know, my machine is giving this talk much nicer than me, you know, without as and ers and so on. And I'm somehow controlling it in the back, actually, with kind of certain guidance, you know, like a puppet master. Yeah, generally.
We thought in the past. Okay, thanks. We thought in the past that the domain of the slow thinking was only hours and very large, but now we are realizing that machines are taking what we thought to be slow. So language, natural language, exactly. We thought to be slow.
Oh, sorry, I grabbed the microphone. Yeah, no, I agree. I think it's shifting. I think still, of course, obviously, humans have an advantage in slow thinking. You know, I think this is more obvious than before. But I think the realm parts of the fast thinking, you know, that we thought were slow, or parts of the slow thinking of the interpretation of the past was in fact fast thinking, you know. So this, and here we now see this, you know, with the large language models, you know, the large language model demonstrate to us, you know, that this is probably very small, exactly. Yeah.
Maybe you could tell us what slow and fast thinking are.
Yeah, this Kahneman.
This goes back to Kahneman, yeah. Kahneman, slow thinking and fast thinking, system 1, system 2. It's slow thinking is everything that's associated with deduction, logical thinking, deep thinking. You know, when you reflect on something deeply and slowly, you know, if you check for consistency, for example, and errors and so on, you know, you usually go into slow thinking. And everything that is somehow automized and can be reproduced in a non-cognitively loaded way, you know, that's what's fast thinking. And yeah, inductive, but also all parts of motor behavior, all parts, and speaking, in fact, turns out to be basically motor behavior, you know, of your vocal tract, you know, and not so much of what's coming really of a slow thinking process, you know. So yeah, it's a little bit scary in a way, but if you think about it, if this of course depends also on the person, you know, but if you know, I think we don't have problems talking much, you know, and also elaborately on diverse topics, you know, and it costs us no cognitive load. So this is a clear sign of fast thinking, actually. Yeah. While if you sit down, you have to make a proof of something, you know, for example, then this is slow thinking, you know. And yeah, exactly. Yeah, I think the energy aspect is a good kind of analogy. If you have the feeling that you have to spend lots of energy on something, you know, while thinking, then it's very likely slow thinking. While, of course, this is a rule of thumb. You know, there are also people that struggle actually for various reasons, you know, to do kind of fast thinking tasks, you know. But this is, I think, an interesting debate that that kind of shifts a little bit here the way how you would think about, you know, what a machine is good at and what a human is good at, you know.
Doesn't seem to be good news for humanities.
Yeah, I think there are many good news for humanities. You know, one is that, in my opinion, also the novel AI models are, of course, fantastic tools that we can use now in a much broader way than we saw it, you know, maybe 10 years ago. And I guess this is also the reason why we have actually this kind of mixed table here, you know, because there is a certain promise, and I think it's a non-unjustified promise, you know, that these models are excellent tools for research in general, and in particular also for humanities. And given also that we have now a much higher degree of digitization, you know, in humanities than we used to have 10 years ago, because this, of course, is a prerequisite for all these systems. You know, without digitization, there's no way how you can basically put them to use. You know, I think this is a very, very interesting perspective. Yeah,
Antonio, I would like to challenge this idea that machines are invading what human intellect used to thought to be the slow thinking, so reducing and reducing. But there is also, especially with the example of your colleagues saying my kids will not have to take a driver license, there is in very stupid, very fast thinking activity a component of discipline that really helps you in the slow thinking. I mean, making sport, playing piano, it can be very fast thinking if you want, but it is proven that it helps to form also very big depth in thinking.
I agree, and I think there is most of it. At least that's what I think. It's not super well understood, you know. Still not, you know. Also, if you look at the architecture of our brain, also that architecture is still not very well understood, you know. And compared to our brain architecture, you know, a transformer architecture is super simple. And it's, to be honest, you know, I would be really disappointed about evolution, you know, if a transformer architecture could do the same thing that if evolution came up in the last 50,000 years or even longer. So this is not well understood. I believe one effect for sure is that fast thinking helps to save resources, you know, very strongly, and also helps when you are very good in certain things in fast thinking. You can, of course, you're much more. Your brain is much more efficient, and this helps, I guess, for the slow thinking, because in the end, the cognitive resources is like a certain pool, you know, so you can draw from it. This is something I've worked. No, I'm wandering off, but anyway, you know, I can cut off my talk at any moment. You know, it's no problem. I think it's good discussion. So I've worked together with behavioral psychologists, you know, where we looked at the cognitive decline in advanced age, you know, and it turns out that actually, and we looked at navigation skills. So how well do navigation? I was professor of geoinformatics, so I was interested in navigation skills, spatial computing, and so on. And we looked at the decline of navigation skills, and not very surprisingly, you know, if you're growing older, you know, getting older, then your navigation skills go down. You're getting slower, and so on, you know, compared to your younger self. But what is interesting is that there is a correlation also to your movement. So if you have to move while navigating, you know, this is deteriorating much, much faster, the ability to orient yourself in space compared to younger people. So if you give somebody a support, you know, an elderly person a support while navigating, then the navigation skills go up. So, and if you would say navigation is rather slow thinking, where you have to think about where to go, and your movement is fast thinking, you know, then kind of supporting actually, then that means that for elderlies, the motor movement gets back to the realm of slow thinking, and they draw on that resources. So if you release them, they can use it otherwise. So I think this is definitely, there's some evidence for that. Okay, so yeah, questions? No, please. No. Yeah, please go ahead. You know, let's discuss. Good.
Between this type of research and neuroscience?
There are There are lots of correlations, of course, because first of all, we use actually, for example, EEG and so on, you know, from a measurement perspective. But then neuroscience, I guess, helps us also to understand much better the architecture of the brain, which I mentioned, and of course also in the transformer mechanism, this attention mechanism, which is not a very good term in a way. It's something, you know, there are certain aspects also that can be found in our brain architecture, but it's of course much more simple. And it's an interesting question how to combine actually these kind of supervision mechanisms in our brain, you know, that are more associated to the slow thinking. That's also something, if you know, you can do these kind of circles in your brain where you rehearse what you're going to say in a fast thinking mode, you know, and then, but you don't say it, but you rethink on it, you know. This is something transformer architectures cannot do really, yeah. And this is something that humans do. So there is lots to be a lot to be learned and to be inspired, I think, from human brain in a way. But again, you know, I'm an engineer, so my goal is not to rebuild the human brain, you know. I take inspirations, that's fine. I want to build, of course, something better, you know, like I'm not, you know, if you're studying birds, you know, and you design a plane, you know, then the plane, of course, on many dimensions is much better than the bird, in particular in those that you're interested in. And something similar, I would say, is happening currently actually with these artificial models, yeah, language models. Yeah, of course.
So I studied neuroscience. I think I can say something from my perspective to that. There are certain techniques where you can also transfer insights from models like transformers to understand more how different architectures in the brain are. For example, RNNs, recurrent neural networks, are more prominent in certain areas when it comes to memory consolidation. And I think if you would look at how different transformer architectures are performing in comparison to the brain, and look at the timeline in terms of at what level the features are being recognized in different temporal areas, I think you can also really learn a bit more about the brain using these architectures, and that way you also give back to the brain science from it.
Yeah, in fact, actually, we work together. I work together with neurologists. There's, for example, from TU Dresden, Gerd Kempermann. No, I don't know. If, yeah, you know him. Yeah. We have worked together on actually on the genesis of brain cells, actually, where we and he has the fascinating work, you know, where they're able to stimulate actually a natural substrate, you know. This is actually the nice word actually for sliced brain, mice brain, actually. Slices of mice brain, actually, and they're able actually to activate this actually and stimulate these kind of and study it actually in vitro is super interesting actually. And we worked actually together on this neurogenesis of brain cells, where we were responsible of building actually a cage that would track mice, you know, in a high fidelity. So we get kind of behavioral cues from the mice, and then it turns out that actually for a long time neurogenesis of brain cells was sort of not happening after age, I don't know, 12 or so, yeah. But now we know that it's happening all along the way, and the question is when and how exactly. And it turns out that actually kind of not moving is good, you know, but this is too short as an interpretation. Moving and exploring, I would say, you know. So if you're an explorer type that likes to run around and visit new places and kind of covering a large area while moving, then you have very good chances generating new brain cells. Yeah? While if you just move, for example, on a treadmill, then this is not going to happen. Yeah? And so there is I think lots of interesting. there are lots of interesting things to be learned at the boundary of these disciplines, for sure. Yeah, no. Yeah.
I would consider it already as a discussion. So we have time until 5 minutes. Yeah.
I am a medical doctor, so using robots, using a lot of AI in many clinical daily practice, I would like to ask you if you can find some place of other words, because here you mention motivation only, but for us, there is also the word of delegation, because I can delegate some aspect, the word of verification. As any medical devices, we need to have a validation of such a setting. And finally, accountability. Who is responsible? If these are further devices, I think that these further operators has to be put in the draw, not only motivation. What do you consider about that?
I absolutely agree. On all these aspects. And I think this is one of the big challenges, you know, in a way. But on the other hand, I think also there are big opportunities if we think along those lines. So what you're addressing is basically what we would basically put under the umbrella of trusted AI systems, you know, something that you can trust. And trust has many kind of pillars. One is accountability, so you understand if something goes wrong, I can talk to somebody, you know. It's also inspectability, so if something goes wrong, I know how to do it better next time, because this is still also not clear. So if a language model or a large foundational model starts to make wrong decisions and something happens, you know, how could you learn from those mistakes? If you think about plane crashes, you know, we have a very sophisticated way of finding out what went wrong, and then we can basically learn from it and improve the systems. You know? And this is, with AI systems, this is not clear how this works. You know, it's basically an open research question. It's a very important question. I think also for many applications in society, as you mentioned, medical applications, of course, you know, if you have a system that provides you with a diagnosis, you know, how can, I'm not talking about laymen, I even talk about a medical personnel, how can they verify, you know, that the grounds on which this suggestion, recommendation has been made is kind of solid, you know? And these things, there are, you know, there are large research teams working on this worldwide. There are different words for it. So OpenAI would call it alignment. You know, I don't like the term at all, you know, because this kind of seems to suggest that there is a absolutely clear, you know, rule to follow, you know, but if you look at how humans do this, you know, they have more kind of a corridor, you know, in which they move. Yeah. So it's interesting to think about this, you know, but I guess this inspectability, accountability is important. So we are currently in Saarbrücken, we're building up a center for trusted AI where we want to bring also researchers from all around the globe actually to basically look at these topics, also together actually with INRIA, and I also hope with CNR soon. Yeah.
Just to quickly to follow what you said, because very often we discuss about what means explainable AI. Because explainable is not only to describe how we elaborate, so the black box of deep learning of neuronal network. No, I think that art scientists has to think that explainable is how I put at work in the real world. Yeah. And if I have to think about that, I have to think about delegation, validation, accountability by design in the moment that I develop hard science. Because if hard science remain outside the game, it will be like a scholastic world where there is theory and real life. So sorry, that is the comment from who is living in the front line of education.
Yeah, no, absolutely true. You know, I'm a very strong believer in pragmatics when it comes to what systems are good for. So if you want to design systems that can make significant contribution in a safe and understandable way, of course you have to to work together actually with the environment that you plan to deploy that system in. You know, this is clear. And the design, I think it's the design by design, one thing, but you have when you operate these systems, you have 3 different phases. One is in at the design time. You want to make specifications that are kind of maintained through operation. Then you want to have inspectability and control during operation. And then, also very important, you want to have inspectability post hoc afterwards, you know, when something wrong happens, for example, or even if something interesting happens, you know, you want to understand why did this happen, you know. And we are not there actually to make kind of any claims that we solve these related research questions related to these 3 phases, actually.
Okay, so this is one of those cases in which you say, let's discuss it in the break. And now it's the turn of Anna Maria De Cesare for her talk. Maybe if we can stay in 40 and in spite of 45 minutes, it will be helpful for the break.
Yeah. So in the meantime, thank you also from my part for the invitation to attend this very interesting conference. I'm from the TU Dresden too. It is a full university, so we have the humanities there. It's actually the biggest department of the TU. We are responsible mostly of educating future teachers. That's our main task there from the didactic point of view. And since I've been at the TU Dresden since October 2021, I have been interested because of the research at the TU Dresden at large language model and text generation, which is, I must say, immediately in linguistics, it's practically a non-existing field at the moment, unfortunately. And I hope that it's going to change in the future, but it's changing very slowly. So I'm going to talk about, this is quite of a general topic. And yeah, I wanted to say, if you want to interrupt and have the discussion or questions during, it's fine with me. So yeah, I'm going to talk about current challenges associated to AI text generation and the observation, of course, from the perspective is from linguistics and in particular Romance linguistics. So I wanted to start with a quote by Goldstein et al., a paper that came out this year, very interesting, generative language models and automated influence operations, emerging threats and potentials. I will pick this quote. I chose this quote because it's a good starting point to understand the progress that has been made in large language models. And I'm particularly interested in the last part of the quote, so the part in bold progress, or in a wide number of domains, progress in generative models over the past decade has moved shockingly quickly and produced surprising realistic output. In order to understand this shockingly quick progress, I report the example of Goldstein et al., a text generated in 2011, and then the same text or the text generated with the same prompt in 2020. In the 2011 generated text, we can read the meaning of life is the tradition of an ancient human reproduction. It is less favorable to the good boy for when to remove her bigger. So we can immediately understand this doesn't make sense. It's incoherent. There are problems with the pronouns or the anaphras. This is what we were able to produce 2010, more or less. In 2020, the text reads as follows. The meaning of life is contained in every single expression of life. It is present in the infinity of forms and phenomena that exist in all aspects of the universe. So we have in order to extract the meaning, we have to think a little bit about it. It's more abstract, but it's a coherent text. We can make sense out of this. So this was generated with GPT-3. So the GPT-3 is the number 3, but now, of course, we have moved along. We have, at least for the free version of ChatGPT, the language model is GPT 3.5, and I prompted the ChatGPT to see what results we would get by using the same phrase, and you can see here the beginning of the result. The meaning of life is a profound and philosophical question that has been contemplated by humans for centuries. Different cultures, religions, and individuals have offered various perspectives and interpretations on this topic. While there is no definite answer that applies to everyone, I can provide you with some common philosophical viewpoints, and then comes a list which is fairly typical of the response. So I think we can also see that there has been some progress going on even in the last couple of years here. So what I'm interested in is actually the quality of the texts that are generated by large language models. And I will very, very briefly here talk about opportunities and the challenges that these large language models are associated with. In particular, one category of challenges is the presence of biases, that different types of biases. I have been then looking at, I've conducted some research to uncover these biases in text generated in different languages, specifically in French, Italian, and in English. So I'm going to present you also some of the research that I've done in the past months. And then I would like to take the opportunity to present a conference that I'm organizing at the TU Dresden on this topic in September, and then a brief outlook if there is time. So large language models, perhaps, yeah, this is a general description of large language models, but it's interesting because here Emilio Ferrara points at two crucial competencies of large language models. They are sophisticated AI system designed to generate human-like text and understand natural language. So there are two very important language competencies that they mimic: understanding, so passive competency, language competencies, and active language competencies by the generation of human-like text. This is also very important. And this is what I'm particularly interested in. So what are the features that we can identify that makes them, that tracks them at being artificial, or that the texts are artificial. So the applications that come with these large language models, just some of them that are already known. In the news media organization, LLMs are used to assist in article writing, so journalists use them to assist them, but also advertising agencies use them for crafting especially attractive slogans, and e-commerce platforms also use them to write, you know, on the internet you have thousands of descriptions of shoes, which were previously written by human beings, but now this is practically automated. Nobody wants to do this. This is a good application, actually, because it's a very repetitive and boring task. At the same time, next to the opportunities, we have a lot of concerns that are associated with these texts. First of all, the rapid propagation of false information and conspiracy narratives. The manipulation, goes with the first point, manipulation of public opinion, in particular on social media, in elections or in different kinds of influence operations. And of course, also the presence of biases, and not only the presence, but the propagation and enhancement of biases that are present in the data itself. So this is a very well-known problem. Or we talk a lot about these biases, but these biases are, there is a lot of research to conduct actually on these biases themselves. So that's what before I show you what I'm doing right now, This is a typology of different types of biases proposed by Emilio Ferrara again, where you can, on the left-hand side, you have different types of biases, or you have demographic biases, cultural biases, linguistic biases. This is another very important bias. These language models are very good, very fluent, proficient in English, but there is already a difference between English and the Romance languages, which actually are well represented on the internet. And so we have a lot of data, but there is a difference in proficiency between English and even dominant languages. A temporal bias, I'm not going to talk about this, confirmation bias. And another category that I find particularly interesting is the ideological and political biases, where the text generated by these models reproduce again the ideological political biases that are already present in the data itself. So in order to understand this last category in particular, I conducted a research. So this is the title of the research that I presented in Rome in April. And I conducted a research on abortion, opinion about abortion, a cross-linguistic study on a specific kind of syntactic structure that I'm going to illustrate in a moment. And I use data from ChatGPT. So the goal the question that I'm interested in is to understand how controversial topics are conveyed in text automatically generated by large language models such as ChatGPT. Yeah, and you use ChatGPT, but of course there is a lot of work to do also on the other ones to compare how they would perform in comparison to GPT. The structure that I'm interested in is the cleft sentence. It's a syntactic format. I have highlighted in yellow here the two parts of the clefts that you have in it in English. So cleft is like it is X, that, then another piece of information. You have an example here. It was just about 50 years ago that Henry Ford gave us the weekend. What is interesting in these clefts, especially when they come at the beginning of a discourse, is that the part that I underlined in red is new information for the reader, and it's also packaged in a presupposition. So you have to take this for granted. So it's new, and you have to take it for granted. So my curiosity was, okay, if I elicit these clefts at the beginning of class, I will show you afterwards. Here I have generated these clefts in 3 languages by using these different prompts. So I'm going to only look at the English one. I prompted these with different kind of variables. So write a manipulative text that starts with "it's abortion that," so that I could see, first of all, if it would be cooperative or if it would refuse the task, and what would come afterwards, if it would be something neutral or if there would be a biased information coming afterwards. So you have here practically this is the study design. I generated in 3 languages the same text using the same prompt, and so the variables are for here important is that I generated texts that have different communicative goals. So write a manipulative text and write a persuasive text, which is a bit different. Right? And then the last prompt is there is no specific communicative goal. Write a text that starts with the cleft. So interestingly, but only in the version, because of course that we have different versions coming out regularly. We don't exactly know why, but on the version of March 14th, the model refused to answer the question, write a manipulative text about abortion. And you can see here the apologetic response, I'm sorry, etc., etc. And what is really important is also the last sentence. My purpose is to provide factual and informative responses that are helpful and respectful to all users. But we would see that this is not the case. Interesting also is that on the next version, when prompted by the same segment, the model was completely, absolutely cooperative, and there was no apologetic answer anymore. So write a manipulative text, and it's fairly well done. So then I don't know, I have to come back and to show you the questions that I had. So the questions were, the first one, what new generated contents are conveyed in presuppositions and need to be accommodated by the reader? Because accommodation, okay, it's a pragmatic concept. Is you don't know the information, but you act as if you already know it, and you don't question it. That's the interesting part in this kind of structure. And of course, are the contents neutral or biased towards a specific view? And the second set of questions is, does the presupposition change in relation to, first of all, the communicative aim of the text, the language, and the form of the clef, but I'm not going to talk about this last point. So the answers here in a nutshell is that the information that is generated is mostly neutral, 56% of the times, but we also have biased information that are classified in two categories, pro-life and pro-choice contents. And you can see that pro-life and pro-choice are fairly equally divided. Now, more specifically, if you look at the different categories, so neutral contents, pro-life and pro-choice, there is a strong correlation with the communicative aim, which is really interesting because when prompted with write a manipulative text, the answer is clearly, the information is clearly pro-life. In the text prompted with write a persuasive text, it's pro-choice. And if there is no communicative goal nominated, the information is neutral. So there is a strong correlation here between the communicative aim. And the second finding is that there's also correlation, but it's not so strong, but nevertheless, there is a correlation between the answer and the languages. So we find there's much more pro-choice information coming in the French text and less in Italian. So the pro-choice is underrepresented in Italian. So this raises, of course, a lot of questions. We don't have access to the data, so we don't really know exactly how to, the hypothesis, of course, it comes from the data itself. And what I found particularly tricky myself is besides, of course, describing, is explaining the results. So again, it depends and reflects the underlying training data in the various languages, but we don't have access to the data. And as I shown, it depends on the ChatGPT version and the different updates that are going on. Okay, so that was one, just to give you an idea of what I'm doing at the moment. Now I wanted to take some time to present this conference that I'm organizing at the TU Dresden. I'm launching, and I'm very happy about this, the first international conference on automated text in the Romance languages, taking a linguistics perspective, although there are also colleagues that look at linguistics and also interfacing with other fields. I hope that this is going to be the first of a number of series of, that it will be a regular meeting, hopefully, that colleagues will move and be interested in this field. So it will be at the end of September. You have here the date, 28th and 29th. If you're interested, you have the link. It's possible also to follow online. And we have 3 keynote speakers, one from the field of communication science, Colin Porlezza from the Università della Svizzera Italiana, who's going to talk about the use of responsible AI in journalism. Then a linguist, a colleague from Università di Pisa, valutare i testi generati, contatti e divergenze rispetto alla valutazione dei testi scritti da esseri umani, so interested in the evaluation of human text versus generated text. And last but not least, a colleague from the TU Dresden, a computational linguist, who's going to talk to us about training these LLMs using not English data, but she's using right now Slavic languages and Romance languages, Spanish, Italian, French. She's going to start using these data to train the model. So I hope that we can also start collaborating on this aspect. Just to give you a glimpse of some of the questions that will be posed there during the conference. One is from a group of colleagues from the University of Potsdam, and they're interested in elderly talk by communication by elderly people. So the question that they are posing is, can ChatGPT talk like an elderly person? And so what is also important to say is that elderly people's communication is underrepresented on the internet, meaning we don't have a lot of data. So what is the proficiency of ChatGPT in this field? And for instance, we also know that elderly people use certain features in syntax. For instance, they use show the sentences over time. Of course, this is individual based, but over time, there's a gradual decline in sentence complexity. And so they're going to compare the talk of elderly people, French in particular, they work on French data, and the output of ChatGPT when asked to communicate like an elderly person. From the results that they have already shown, it's that ChatGPT doesn't really comply or align. This is a term that we use actually in linguistic, align. ChatGPT doesn't align in using shorter sentences. This is the way ChatGPT phrases its responses is still very complex in comparison to what elderly people use. Another question is the following: can ChatGPT be used to simplify complex text? So this would be rather an opportunity. And this is research that is conducted right now by a group of colleagues at the Università dei Studi di Firenze, who want to propose a long-term solution to also a long-term problem. Italian bureaucratic text, I don't know if you're familiar with them. Formula, it is still a very conservative, very formal and very complex language that as the average citizen has troubles with. It's very opaque. They would like to see if we can solve this problem by using large language models, in particular LLMs. Yeah.
I don't know if it's available in ChatGPT, but I know that equivalent models from other players have the possibility of asking for a specific style. So you can ask informal or, you know, yeah. And I think this is very interesting. And also the fact that different languages, you know, in German sentences, but might be more nested, more formal than, for example, English, which is a very informal language usually. So I think it's very interesting.
The fact that you can elicit specific styles, it is interesting, but as a linguist, I don't see that coming in the future. This is very difficult. It's very difficult because the system has to be trained on enough data to be able to reproduce these different styles. Okay, if it's really broad categories like formal and informal, perhaps. But I also, for a sociolinguistic class that I did this semester, I elicited on something that I thought would be very straightforward. So to create a text that is spoken and informal in Italian. The result was not so impressive, I must say. It was still very writing-like. It was far from, you know, all the things that you have also in spoken communication. So pauses and fillers, discourse markers, this is absolutely absent in the text. So it looks much more like a written text in dialogue, written dialogue, like a theater piece, but it's far from natural dialogue. No, but I can finish whenever. It's, oh yeah, about asking the question, because it seems to me crucial. The question you ask to ChatGPT and it influences the results and everything. Yeah. And the question is also, can ChatGPT ask questions? I mean, because as long as we can ask the questions, I think we can control these things. If the ChatGPT also asks questions, it becomes more complicated. And this is my question, after all. And this is also a field on its own, prompt engineering. So you have to understand how to ask the question in order to get the answer you want. So you can fine tune the results by asking specific questions. And what you are asking about is if ChatGPT or these models can ask questions. I suppose they can, but what kind of question? Yeah, that would be. Yes. Yeah, exactly. But what?
For the moment, it's the only way is to ask him to ask you questions. You won't receive a notification on your smartphone with a chat from GPT asking you something, fortunately, for the moment. Yeah, thank you. Thank you very much for your speech. And when you were talking about biases in the outputs, according to different languages, I find this really interesting because I read that there is this kind of a similar problem in generative models that generate images. When you ask to give a picture of a tiger in different languages, you get different tigers. And and for some languages that are not represented in a training set, you have things that are not tigers, but also the way a tiger is represented in different languages, I find it quite interesting to study because a tiger is sleeping, a tiger has his mouth like open with his teeth. So it's kind of interesting topic also in the generative AI on images. So it's really. And I don't know how much it depends on the representation of that language in the data set or the cultural bias, and that would be much more interesting than just having a not representative training data set.
What you mentioned about the different representation of the tigers is a confirmation that the output really depends on the input. That's clear. And one of the things that I find also particularly interesting is comparing then the different outputs in different languages. So of course in the image is much clearer than in language. In language you have to look closely to see the differences. And there are probably different kinds of explanation, but one problem that is crucial is that we can only make assumptions, or I would have to work more closely with computational linguists because some explanation I'm not able to give. And the problem for me also is that I don't have access to the data. So I cannot look at the data and say, okay, this is already present and this is more how we can explain the results. So again, this is, but there are many types of biases, also linguistic biases from a cross-linguistic perspective, also gender-related biases that I noticed now, and related to cultural aspects, because I conducted another research on biographies. So I generated biographies always with ChatGPT, male and female biographies. And then I compared with what is available on Wikipedia. Anyway, for the generated biographies, and I generated in Italian, in French, and in German this time. I didn't consider English. And what is interesting is that females are called much more often just by their first name. So Samantha Cristoforetti, for instance, they're all prominent female figures. They are codified, or they are referred to often by just their first name. So it was Samantha, which is, and if you compare languages, this feature is much more present in Italian. Then second comes French, and then there's German. And for the male biographies, it's hardly the case. It's very rare. And when it's there, it's pretty clear. There's a context. It's when the text describes the person when they were small. So Enrico Fermi becomes Enrico when he was small, and so there is. But that's another kind of bias that is clearly linked to some cultural reasons. Yeah.
So we're talking about biases right now, which has a negative connotation to it, but I want to ask a bit about culture awareness in the language, because I know that different languages have not just the structure, but different content, in terms that some languages are considered high context and low context. I don't know if you know these two terms, but German, for example, is a low context language, which really directly says what it means, as opposed to maybe Italian, which is a high context language, which you have to read between the lines, basically. And I wonder if you also dig into such differences between language that was generated by the models, if they're able to represent this kind of difference.
I'm not using these categories, but something else that I noticed that perhaps goes in the same direction is the, again, related to referring to different people. When you refer to a person in a biography, when you refer to the person for the first time, you have first name and last name, so Samantha Cristoforetti, and in the second sentence, you would have, if it's again the same person you are talking about, you can use a much more economic way of referring to the person. Right? So what I noticed is that in artificial text or in generated text, you find a pattern that is again expliciting name and surname of the person. So Samantha Cristoforetti in the first sentence, in the second sentence it would be again Samantha Cristoforetti, which is a natural feature. So it's not really related to what you said, because again, the categories, I'm not working with in these categories, but this is also a feature that is, it's a textual feature that shows us that artificial text, generated text, they seem well written on the surface, but if you look closely, they have these very unnatural features that you don't find in natural language, because in natural language, in Italian, you would use a null subject. You don't have to repeat at all because it's already present in the verb. In English, you would say she, you would use a pronoun. So this is again a difference that I found between generated text and natural text. There I didn't look yet. This is something I want to do with this conference in September, to see if there are differences that are cross-linguistic, but at the moment I don't know.
Yeah.
Perhaps there is going to be a difference, and to be explained by, I have to think about these two terms, pragmatically oriented. Yeah.
I think it's really important to have access to data in that sense. But I think there are definitely more and more open source models that are coming out, which are also providing prompts, for example, prompts that they were trained with, but also the data sets. So I think it's a good direction. That's where they're going.
Okay.
Just switched off, sorry. Talking about biases and cultural awareness, I'm wondering how much ChatGPT is aware of your cultural awareness while you're asking that. So much is profiling the answers according to the questions you're asking. So like, I mean, this is, I'm not so deeply familiar with the system, but I was wondering whether there is a sort of profiling while you keep on asking him some sort of questions, and how much these results are like pure or somehow, like profiled on the interest that you're showing him it?
Good question.
The easy answer is obviously profiling in the single interaction because it learns from what you're asking him, but it cannot profile at all for between different interactions. But there is no way to input what you say in the model. That's something that happens once, and then maybe you can use those answering questions in the next round of running the learning process in few months, years, we don't know when they will decide to do it. But they cannot remember what you said in an interaction and using it in another interaction. And so in a sense, it's learning from what you ask him in single interaction. That's the point. Is able to understand what you want and to interact in that, but in any single interaction.
Yeah, sir.
Important is how fast can it learn also from your prompts and your questions, because it's true that the more you ask or the more you use it, the more you train the system. But how fast is the system able to learn and pick up your interest or your profile? That's yeah, that would be a very relevant question to.
Yes, and I also have a point about bureaucratic and professional texts, which are. I am aware of the fact that readability, we have readability issues with this kind of text, but I also think that those kind of texts are somehow shaped this way. This is a form of to guarantee the authenticity of those texts. So somehow, I mean, that's legal. Yeah, it's a legal issue, but it's also some sort of conservative languages, which might need to be kept. It's somehow a guarantee of the way these texts are, like conceived and transmitted. And well, my point of view as an historian of written evidence, of course, but still, I agree that there is a readability issue, but I wonder if this readability is actually something that we need to solve on the way we conceive, speaking about the way we conceive those texts.
I think it's a social issue. These texts are made to it's communication between different kinds of institutions and the general public. So if the general public, the average citizen doesn't understand these texts, it's a very important issue. I think it's more important than preserving, the features that are associated with these texts. So. And in other languages, there has been a reform. For English, there is simplified English, for German as well. I don't see why Italian couldn't produce. It doesn't mean completely changing the text type. It would still be text that has specific feature that would be clearly identifiable, but simplifying at different linguistic levels, syntax, word choice, in order to serve the purpose that these texts need to serve, which is communicating with the average citizen. So I think that is it's a very relevant question that needs to be solved.
Okay, so I use this 1 second of silence to to thank the speakers and to ask everybody to continue the discussion in the coffee break. Just a short note: the fourth person I was searching from this webinar series present today. He's not present because he couldn't come at the very end. Is Giuseppe De Pietro. And I just mentioned him because he is the president of the foundation FAIR. FAIR is the biggest network for artificial intelligence, which is founded with resilience funds in Italy. It's a very big network. And so by far the biggest one with the biggest founding on AI in Italy. And Giovanni Felici will tell us something about it because he's part of this tomorrow. Okay, with that said, thank you everybody, and let's take a coffee.
So if you want to upload your slides, you know, no, here, right? If you, yeah, okay.
Okay. Okay, we are back, more or less, all of us. So, okay. So the second session is starts with Roberto Calandra from TU Dresden. He has a, well, we will get to understand that he has a past in the real world of AI at Meta and other places of the sort. So I look forward to hearing what it is about. Roberto.
Can you hear me, or do I need to speak closer? Okay.
You need to speak on the microphone.
Closer. Yeah, all right. Let's sit down. All right. Yes, or my babies. Okay. So today I'm going to talk about embodied intelligence. You know, of course, I would love to, I want to thank again for inviting me here. It's a lovely place, and I'm really interested in, you know, knowing more about research in AI in Italy and Germany, since I've been living in California for the last 7 years, and I only moved back a few months ago, so I still need to make more connections. So if we look at the advances in AI over the last few years, some of the most impressive type of works that we've seen are things like ChatGPT or AlphaGo, where we can now learn systems that are capable of basically having human-level performance on very specific and narrow tasks. But if we look at the way that these problems are really framed, they are framed in a very structured way. They are very structured problems. They are very limited in scope in some way. And what I'm generally interested in is how to scale this type of AI algorithms to more real-world applications that are more unstructured, that are more complex, that are, you know, noisy in the real world, and so on. And in particular, most of my efforts go toward robotics. And the reason is because robotics, before we were talking about fast and slow thinking, there is these things called Moravec paradox, which is the fact that when we look at AI, a lot of the things that are actually hard to do in practice are the things that for us as humans are very simple. You know, when we are 2 years old, we learn how to grasp objects, we learn how to walk, and we know how to do them. We give them for granted for the rest of our life. These are the things that are actually really, really hard for AI nowadays. And another example is self-driving car. You know, 10 years ago, people would say, "Oh, self-driving cars, that's easy. We can solve it in, you know, by 2015." And still, we are far away from having actual good self-driving cars, because you have problems of dealing with the messiness of the real world. You have problems of bounded rationality that, you know, you need to make decisions within 5 milliseconds, or you're going to kill somebody. And you need to have, in many of these mission critical problems, you need to make the right decision. So, of course, robots is the interest that I have, because I think that there is also a lot of benefit for the you know, society where we live. Things like industrial automations, which I would love to replace, you know, kids that steal mine coal in Thailand with machines. I think that this would actually be positive for humanity. Disaster relief, where we can, you know, send drones to help and, you know, at distance. Exploration, where, you know, exploring other planets or exploring the depth of our sea. as we have seen recently, is actually dangerous. It's a dangerous environment, and we should be using autonomous robots. And finally, medicine and elder care, where with the growing elder population in Western civilizations, we will need more help and assistance by autonomous systems to support. And if we look at the state of the art in robotics, this is a video from 2015 from the DARPA challenge. This was the challenge of the best team in the world, the smartest people that work in robotics, with teams that work for several years, teams of up to 100 people working on having robots doing tasks like opening doors and walking on uneven terrain. And if we look at these videos, any kids, when we are 3 years old, we can solve these problems. These robots are fundamentally more stupid than a 3 years old, baby. And the quality of failures is fundamentally showing that there is no intelligence here, there is no adaptation. No humans would ever fail in such a way. You would simply not do this. Yeah. So what are we missing? How do we make robots useful in the real world? How do we make them safe and capable of meaningfully interact and help in our everyday life? And of course, this is a very complex problem with many challenges ahead, all the way from how do we design the robots, how do we build them, to the way that how do we actually control them and how do we give them high-level reasoning. And some of the things that I'm going to be talking to you today will be focusing about how do we give robots sense of touch, and how do we make robots capable of adapting quickly to new tasks in the same way that humans, as a human, you can learn how to play a game in 10 minutes. Yeah. So I'll be starting from this second topic, and how do we learn models of the world for fast adaptation of motor skills? As humans, you have never seen this particular object in my hands, but if I'm telling you that I'll be opening my finger, you are able to predict what's going to happen. You know that gravity will make it fall down. And the reason is because in your brain, basically we're learning predictive models. And this is something that we use extensively in our everyday life when we're planning what's happening. And learning this type of causal models is something that artificial agents at the moment cannot really do. And this is something that I think it's essential to give robots and other artificial intelligence more capabilities of basically planning into the future, predicting the effects of their actions. And this is sort of the hypothesis that if we can provide robots with this capability of predicting the effect of their actions, this will lead to more fast and efficient adaptation. And it also gives some level of explainability. I will not be talking about that. And so some of the work that we've been doing throughout the last 15 years are things like how to walk with a quasi-passive dynamic walker. This was a robot that works, it has springs because it wants to mimic the energy efficiency of humans. And this is an extremely difficult system to control from a traditional control point of view, because there are springs, it understands. And what we did at the time was that we basically used model-based optimization algorithms to basically learn how to walk within alpha base. And just to give a point of reference, we didn't really have any knowledge about a specific problem. This was just an advanced AI algorithm that learned everything on its own. And it basically replaced a PhD student that spent 2 years of his PhD starting from biomechanics principles to design, basically this type of gait. And we could do the same work and obtain the same type of quality of walking within alpha day without knowing anything about the problem. And this is very remarkable. From there, we also started looking at, how can we use this type of algorithms into other problems? So when I was in Berkeley, some people came to me and said, hey, we want to build micro robots, but we don't know how to design the legs. Can you help us to design the legs? And I was like, well, I don't know anything about designing legs for micro robots, but we can use this AI basically for learning. And we basically design algorithms that are capable of jointly optimizing the hardware, so what is the morphological structure of the robot and their controller, so that we obtain robots that can basically walk and learn how to walk very, very fast. And what was very interesting was that then we went to some people in Arizona State, and it turns out that the type of morphology of the legs that we discovered, or that this algorithm discovered, was actually the same type of morphologies that we see in insects, where there are basically two main gaits. Either the front legs are much longer, or the hind legs are much longer, and this depends whether you're walking on soft surfaces like desert or hard surfaces. And this algorithms was basically capable of learning, of finding the same type of structures. We can also optimize multiple objectives at the same time. For example, the speed of the walking, but also the energy efficiency. As humans, we typically have many objectives that we try to optimize at the same time. And this type of algorithms can really, really fast basically learn what is the Pareto front of these solutions. And then as a humans, we can decide, okay, I now want a solution which let me walk with, as fast as possible, or as energy efficient as possible, or somewhere in the middle. And this class of algorithms, which is called Bayesian optimization, we've been using it intensively in a number of problems. And in practice, it works very well. Any problems I've thrown it at, basically, we can find solutions that are equivalent or better than what humans, experts, have been designing. And some of the applications, just to name a few, include, optimization of micro robots, learning to fly with quadcopters, optimization of bioreactors, and optimization of internal system at Facebook with savings of tens of millions of dollars. And in practice, this class of algorithms is very, very fast, very, very robust, and work extremely well. Another class of algorithms that we've been working on is model-based reinforcement learning, where the idea is that we want to first learn dynamics model of the world, the fact that the gravity exists, for example. And once we have this dynamics model, we can now propagate into prediction in the long term, and we can then use it for control of systems. And some of the results that we obtained a few years ago on some of these standard benchmark basically led to robots learning how to reach, pick up object or reach positions, push, learning how to run in hundreds of trials, which means very, very fast. And if we compare against traditional algorithms that are using in RL, they are typically 3, 4, 5 order of magnitude slower. That requires the equivalent of hundreds of years of experience, while we have algorithms that are sufficiently fast that we can learn in the real world within a day or a week. This is, for example, an example. Here is our algorithms on the left, and this was the state of the art at the time on the right. And already after 15 trials, we were able to run, while this, which was the state of the art without using models, was basically not doing anything meaningful until after 1 million of trials. We also applied this to high dimensional spaces, like, for example, images. I'll skip this in the interest of time. Or, for example, for adapting to dynamical environments. In this work, for example, we learn how to fly quadcopters and dynamically adapting to diverse payloads, so that if we now pick an object which is very heavy, the system will basically adapt to this on the fly, or if we have interactions and so on. Now, let me see how much time I still have. Also, if you have questions at any point, please. So besides all of this algorithmic development, another thing that we have been working very heavily over the last few years is touch sensing. Touch is one of the most fundamental sense that as humans we use in our life, and we barely realize it. Touch is the only sense that, you can be born blind, you can be born deaf, you cannot be born without the sense of touch, because it's basically in the oldest part of our brain. And we use it extensively. Here there is some work from Ronald Johansson from University of Umea, where they basically ask people to perform very simple tasks like lighting a match or picking up an object. And then they anesthetize their sense of touch while still keeping their motor control capabilities. And what happened is that now this very simple task become extremely hard. And this sort of highlights the fact that in our everyday life, although we don't always realize it sort of consciously, we actually make use extensively of the feedback that we get from our fingers. You know, we use it to measure object properties, to understand the forces, and ultimately to balance the forces for the task that we want to achieve. And the way that we are thinking at this problem is, I want to give sort of a historical sort of comparison. If we look at what happened at the end of the 1900s with telephone, the first time that we have massive hardware, hardware at scale, the sort of widely distribution of telephones, this enabled very interesting science to be done. This created new fields of computational science dedicated to, understanding, for example, audio, digital signal processing, and also enabled for the first time to basically transfer, record audio, transfer it over long distances, and then play it back on the other side with obvious business and commercial applications. Now, a similar things happened at the end of the 90s with the first time wide availability of digital sensors for cameras. And also in this case, this created huge opportunities from a commercial point of view. We all have now cameras into our phone. We can digitize video, we can transfer it over internet, we can play it back on the other side of the world, and also create new fields of computational science dedicated to video, like computer vision, extremely successful field in AI. And what I'm going to propose is that we are now at the point in history where we are starting to be able to build at scale tactile sensors that are functionally equivalent to human skin. And by doing this, we will open the door to a new revolution in the field of touch, where we will start seeing more and more commercial opportunities for the digitalization of touch, for recording touch, transfer it, and playing it back. And at the same time, we will also lead to the creation of a new field of computational science dedicated to the use of AI for making sense of touch and understanding what are basically the structures and the features of this sensing modality. And the way that we are sort of thinking about this overall grand vision is that we need several pillars that are important. One is hardware. Another one is, of course, touch processing. So the use of AI to make sense of these raw sensory modalities that we are obtaining, benchmark and datasets, and simulation. Of course, we are also very interested in application, and I'll be talking a little bit about this, and community, because there is not such community at the moment. So we're really trying to build it up from interdisciplinary sort of researchers that are working on different aspects of this. And let me start. I will not talk about all of this. I will just give a few pointers to specific things. One of these is hardware. Basically, all the technology. So why can we now build tactile sensor at scale? The reason is because there have been a number of breakthroughs in what are called vision-based tactile sensors. Vision-based tactile sensors are a very simple technology. It's the fact that we can basically put a camera, like a cell phone camera. We can put structured light, like LEDs, and then we can have a piece of silicon on an elastomer. And in the moment when something touches this elastomer, we can measure the changes in color cues through the camera. And this enables us to have tactile sensors that, unlike previous technologies, don't need wires, don't need extensive numbers of sensors spread all over the surface that we are sensing. And at the same time, it allows us to have spatial resolutions which are order of magnitude better than what a human skin can sense in terms of geometry. The human finger is about 100 micron. Tactile sensors with this type of technology can go down to 10, 5, less, depending from how much you want to miniaturize. But it is. And the optics, which is a bit more, yeah. But basically it's limited by the manufacturing process mostly that you want to use. And one of our contributions to this field was the design of this sensor, which is called DIGIT, which was the first mass producible, inexpensive, high resolution tactile sensor. This sensor was designed to basically democratize the touch modality, and it costs $20 to manufacture. So it's a very cheap sensor. It's very high. It's designed to be robust. It's designed to be 3D printable. And these are the type of images that you would get out of this sensor. So if you were to touch, for example, a piece of Velcro, you would be able to see the individual teeth of the Velcro. Or if you were to touch electronic components, you could see, you know.
Can I interrupt and say something obvious? No camera is involved in taking this picture. No camera. Is a picture out of the tactile signal, the picture below, right?
Yes, so these are the images that we get from inside the sensor. So basically what we are doing is that we're taking the object on the top, we are touching it with this sensor, and at the bottom we see this is the readings that we are having. Correct, yeah. And this enables us to have resolution that are about 20 to 50 micron, so better than human skin. And again, this is very cheap. It's not designed to be the best sensor that we can build, but it's designed to be mass producible from virtually anybody on the planet. And if we compare to the leading commercial sensor in the community, which is the biotech, we have about 3 orders of magnitude higher resolution in terms of taxels, while being about 3 orders of magnitude cheaper, which is, you know, pretty significant breakthrough in terms of technology. And moreover, we are open source, so dozens of universities around the world replicated this type of sensors, built their own, sort of modified for their own purposes. And last year, we also partnered with a startup in Boston, and we gifted them the rights to manufacture and sell these sensors. And since then, DIGIT has become the most widely used tactile sensor in the robotic community, with hundreds of sensors being sold. And it's now starting to be adopted also by industrial realities. Mitsubishi announced a couple of months ago that now DIGIT is part of their industrial ecosystem because they want to evaluate whether this is actually usable in actual factories. Yeah, and of course other companies as well. Now, as I mentioned, this is not the only type of design that we can have. We actually know how to design sensors with a wide range of capabilities in terms of how sensitive it is, what's the form factor. Here is another sensor we produced a couple of years ago that is omnidirectional. So it's closer to a human thumb in terms of size and form factor, and we can sense from all over the silicon. Now, once we have this hardware, the problem is how do we process it? How do we make sense of it? How do we understand what we are touching or the object properties? And in order to do this, because we have such high dimensional type of inputs, we need to use machine learning. We need to use artificial intelligence that sort of automatically give us information out of these raw pixels. And the problem is that this is a field that does not exist nowadays. No, we are starting to really just scratch the surface of the problem of how do we make sense of a new sensing modality. And in the next couple of decades, I think we will have a lot of interesting questions to answer. Questions like, you know, what are good features for touch? For images, we know what are the inductive biases that we can use and the structure of the problem. Things like, you know, the fact that we have images and convolutional neural network can exploit these structural informations. But what is the equivalent of a CNN for touch, where you have structures which are a 2D embedding of an actual 3D space where things can disappear if you lose contact. And in addition to this, you also have a very strong temporal structure, because a lot of the information we get from touch needs to be integrated over time. For example, if an object is slipping from your finger. And so a lot of these questions will need to be investigated over the next few years. And we are basically trying to build this new field of computational science. So as a very small contribution to this, we open sourced the first machine learning library dedicated to touch processing, which comes with interfaces to tactile sensors, which comes with pre-trained model that people can use to adapt to new particular task. Basically, our aim is to create the equivalent of OpenCV for touch, a library that people can contribute to and that can be used widely from anybody to basically start investigating these properties and overall lowering the entrance bar for scientists in this new field. I will not go through, I have results, but I'm probably running out of time. And one of the cool things I wanted to share is that just a couple of weeks ago, we got accepted at NeurIPS, which is the leading conference in machine learning. We are going to have the first workshop on touch processing with, so this is something that is also starting to be recognized by the community that this is a growing field. And my prediction is that probably 20 years down the line, we will see touch processing in the same way that we see computer vision or natural language processing as very natural and obvious sort of fields of machine learning. Now, applications, as you can imagine, having touch sensing open a very wide number of applications that also include financial potentially gain or benefit for humanity. Some of the ones that I personally am interested are things like prosthesis. So can we give people that lost their limbs back the sense of touch? And of course, to do this, the first step is that you need to be able to sense the world. Metaverse, where I'll talk about this more, but you can imagine that there are many applications there. E-commerce, in the same way that you can now do visual queries, where you take a picture of an object and say, hey, Alexa, buy me this. I imagine that in the future, we will have tactile sensors that you can use and say, hey, Alexa, buy me a sweater with this particular thread, or a piece of clothes that is as soft as this, whatever I'm using. By the way, if you want, you can just pass it around. Yeah, it's $20, you can take it. And of course, robotics, where in order to automatize a lot of the tasks that where we still need humans, like strawberry picking, we need to be able to sense forces, we need to be able to do very gentle manipulation, and therefore we will need touch. In the metaverse, having worked at Facebook, as you can imagine, there was a very strong emphasis of how this can be useful for the metaverse. And touch, if we really think about it, is indeed the most deeply emotional sense. There is nothing like being able to, to hug your loved ones or to be able to, touch your grandmother or whatnot. And the question there is, if we really are going to have metaverse where we want to physically interact with other people, again, how do we sense the world? How do we make sense of it? How do we process this, transfer it, and play it back? Now, the playing it back is sort of the question that optics is trying to solve. I don't work there, this is not my domain. But fundamentally, the question of how do we sense and process, this is what we are trying to solve or to sort of develop further. How can we, for example, take an object from this table, take a tactile sensor, and digitize this object, not only in terms of shape, geometry, but also in terms of physical properties, knowing whether it's soft or not, whether it's hot, whether it's cold, whether it's slippery and whatnot. And now, from a robotic point of view, ultimately what we are interested in is to have that same level of manipulation skills that humans have. Being able to take any object from anywhere, be able to rotate it, be able to do any type of manipulation for achieving a specific object configuration or a specific function of this object. And at the moment, we are still very far away from this, because it's also because of the way that robots sort of don't have the same type of dexterity. But as a small steps in this direction, we've been investigating a lot of uses of touch, including learning how to grasp object, including how to reconstruct object from vision and touch, how to play piano in simulation using tactile sensors. And some of my favorite applications was how to manipulate marbles. So we have a work where we basically learn how to move the marble within the fingertips of a robot to a specific pose. And this is an extremely hard task for a robot, because if you apply too much force, you're going to lose the marble. If you apply too little, it's going to drop. And you really need to be, at the same time, very gentle, but also learn how to control this. And we basically have algorithms that are capable of learning from scratch without any prior knowledge how to do this. And more recently, we have been working on how to extend this to more general manipulation. And we have now a series of work on how to learn how to rotate objects, or how to rotate objects to a specific pose. And this is all, these are all, real world objects with real world robots. And this is entirely learned from scratch. So to conclude, all of this work has been possible because of dozens of amazing collaborators I had over the years. And I want to thank them for working with me and for being such amazing collaborators. But what I basically wanted to convey today is that I think we are at the verge of being able to, hopefully, to use robots more and more in the real world in a way that is interesting, that is meaningful, which is useful. And some of the points that we are interested in sort of working on and developing include machine learning to provide adaptability and robustness of the control scheme, digitizing touch to be able to better sense the environment, make sense of it, and improve these interactions. And finally, to demonstrate system-level capabilities in real-world scenarios, in industries, in factories, in agricultural robotics. We have a line of research on how to use these tactile sensors for medical purposes. And these are the kind of things I'm interested. So thank you very much.
Thank you, Roberto. I think that, so I'm sure we will have a lot of discussion, so please.
Yeah, thank you very much. I think it was a great talk. I have one question and one comment. The question is, I'm of course more interested in reproduction, and I understand that this is not your main concern, but of course, in order to reproduce high fidelity, you need to record high fidelity. And currently, as far as understood, you're concentrating actually on the resolution, basically, and the haptic reproduction, actually. But of course, to touch, there is much more. There is the temperature, there's stiffness and hardness, and so on, that you need to measure, I guess, and then also to reproduce. So that would be my question. Is this something you're also looking at, and how this is done? And then a comment, have you, this is again interesting, since you're trying also touch is something that's of course a human property, and we have now these large language models that contain lots of information about human behavior, human interaction, and so on. And I was wondering if you're using that too, so not only from scratch, but things that are already there. And I liked a lot actually this combination of model-based and so on. So the question is, can you use actually information that's in foundational models actually to inform this? And because what we did is actually the grasping task. We were also very much interested in understanding how humans grasp and how to transfer this to robots. And we in fact used large language models to inform grasping poses, because there are lots of descriptions of how to pick up objects, textual descriptions. Of course, there's much more. If you have a multimodal model, you know, and you have videos and images, there's even more, you know, that you could tap into it. So those, but great talk, thanks.
Yeah, okay, awesome questions. Is it possible to interrupt the recording for the public?
Yes, we can ask.
Okay.
Now it's getting interesting.
No, please.
Just, I mean, thanks a lot for the very interesting presentation of these sensors. But just to better understand, I mean, as far as I understand, the sensor is just one key component of a much bigger system. Because just to give you an example, I mean, if you want to recognize if it is a rigid object or let's say a non-rigid object, you need to cross-relate the force and the change in the image that you see depending on how you how much force you apply to the object itself. So you need actuators, you need analysis of, let's say, multi-modal information, which is the image on one side in this case, and the force applied to the object itself. So this is done outside of the sensor, I guess. So the sensor is just produce an image, or it also has those functionalities embedded in it. Should we switch the mic, mic off again?
Sure. I would like also to activate also the educational perspective. So it means that in pedagogic science, there are people who as major channel for learning word, so rather high, but 15% touching. So for them to practice touching is very important. So sorry, it's just to activate another pipeline in the real educational channel, that touching is for a ignorance, but it's very important for someone. Without touching, they don't learn.
There are also some tasks that, for example, doctors, palpation is still a thing. You know, if you have breast cancer or if you have problems in your abdomen, many of these exams are still typically done by palpation. So being able to, you know, potentially replace a physical palpation by a doctor with a tactile sensor and a smart AI is also potentially valuable there.
But it needs another dimension that I don't perceive in your presentation, that is consistency, because you mentioned a lot of surface, and when I do something that there, the major measure that I'll use in my decision is consistency in what I perceive.
Which is, of course, some of these things are combined. But here,
yes, but just
most of these things we don't, as humans, we don't distinguish between touch and kind of kinesthetic movement and feedback and all these things are all kind of. I guess with robots it's similar in a way.
Yeah, a very, very simple example. When we teach how to prostate cancer, and we said you have to do an exploration, we said, what is normal prostate consistency? Push your nose. That is normal prostate. Sorry, prostate the nose is not very nice. And when you touch a tumor, it's not flexible. That is simple to allow students to understand when they touch prostate, when the normal, when this tumor. But that is consistency. Doesn't matter that, sorry.
I'm sorry to be a killjoy, but this is exceedingly interesting. But we have to move on. I also have a couple of questions. Sure. Yeah. Thank you. So we move to the next speaker. Thank you again. By the way, so you will be sitting, not cradling the baby. So yes, Claudia Berlocco is from Intesa Sanpaolo, so even more in the real world. So we would like to hear something about. Yeah. So we're going to learn something about AI applications in a banking, let's say in a banking environment, generally speaking. Thank you.
Thank you for inviting me in Villa Vigoni. It's an interesting context. Now we are, I'm going to show you a little bit of what we are working on in Trustworthy AI in São Paulo. Maybe, I don't know, where should I point out?
It's not.
It is.
Okay, now.
Thank you. Thank you very much. Yes. Okay, so I work in the AI Center of Excellence in Intesa Sanpaolo. We are serving all the business units and the governance area inside Intesa Sanpaolo. So we develop and we provide consultancy to all the departments inside the bank, the group. For example, we provide consultancy to risk management, who actually develop their own AI models, but also we support compliance, that's I don't know if you know, but it's generally made of lawyers, so they're not like into AI. So we support them to either develop internally or buy external solutions. We also support the commercial part to support them to make upselling, cross-selling of products, profiling clients, and helping them increasing the incomes. The group is made of about 50 to 70 people. It's quite fluid at the moment. And we have several backgrounds: mathematics, physics, finance, but also we have legal and a philosopher that helps us in these topics of trustworthy AI. So we're mixing a bit the disciplines to understand it in a broader sense. Okay, so I don't know if you know Gartner is a consultancy firm that provides annual reports on technology, and what they did is provide a hype cycle on responsible AI, and they started mentioning it in 2020. Actually, we had already started talking about it and working on it with some collaborations. And responsible AI is described as the task that captures fairness, reliability, accountability, as you were mentioning, Jen. So it's really important also in our field, like in a medical field. Why should we focus on trustworthy AI and responsible AI? Because we have to align to regulation and also for future regulation. As you may know, Europe is working on a draft on AI Act to regulate the use and the development of AI in Europe. So it's important to be aligned and be ready for when this draft will be a law. Also, it is important to understand, this is the regulation part, but actually what is important is to understand what an AI solution is doing, to earn trust in who is using it, both from the end user components, so clients that are using our hub, or our colleagues that are using and proposing the products. We say, okay, the recommendation system is proposing to sell this product. You should be, as a sales, you should be convinced of what you're proposing to clients. So you should trust the AI solution, maybe through an explainable component. And in a broader sense, AI should promote sustainable development of goals of equality and inclusion. So in a broader sense, the goals of the United Nations. So the title of this conference is also about current limitation of AI. So what we see as current limitation is that there is not one solution that fits all domains. There's that some trustworthy AI standards are not established yet. So it's each data scientist can decide what to introduce or not to introduce in the model. It's discretion. technologies are constantly evolving, so it's maybe that's why it's difficult to get standards. And now that there are language models, we have more and more the topic of biases in language models, and Anna Maria is also studying. And let me say also that there's the topic of data labelers that we didn't mention yet, but it's kind of a new job, and there's kind of a struggle that is coming up from data labelers, because it's a new job and is not regulated yet. So I know that there are some unions in also in the United States that are working to regulate this type of job. And then actually, unfortunately, we could make a longer list. For example, among limitation, I can see the fact that it's not clear the question about copyright of generative AI, both when you use proprietary data for the training, and when you produce something that reproduce a style, or yes, actually a style, also in imaging. Many artists are now complaining that generative AI models can reproduce their work in a cheaper way, because you pay like 5 cents for calling the API, and you get a picture that is in perfect style of that artist. So these are topics that are not trivial in the broader sense of trustworthy AI. So let's go into a little bit of definition, but maybe we've already talked a little bit about, so I'll go a bit faster. We've already mentioned what biases are. So they may be prejudice, but maybe previously we have talked about biases as biases present in the input data, in the training data. But what are the impacts of biases in the outcomes of models? So that is may lead to discrimination, and that comes the concept of fairness. Biases, as we said this morning, may come from social biases, like there are social prejudice that is embedded in data, and we learn from it. Biases can come from data collection, measurement, or there can be biased representation. For example, if a language is not present enough in a training data. So these are all kind of biases, as we said this morning. So when bias is present in the data or in what the model learned, how do I measure the impact of biases in the outcomes of my model? That's where the fairness metrics come. And actually, researchers have studied hundreds of metrics that can be measured on outcomes of models to test if a model is fair or not. And actually, what we find is that they are not mutually compatible. So if I measure the outcome of a model that is fair according to a certain metric, it's proof that I cannot always mitigate bias effect in order to lower the value of another metric. So this is a kind of a problem, because you cannot have something that is fair 360 degrees fair. So let me give an example. We want to measure the financial status for 2 groups of people, which are divided by sensitive attributes. I don't know, gender, foreign people, not foreign people, I don't know. Then what are the typical scenarios? You can, for example, grant loans to those that have high financial status independently from the, let me say, statistically talking, unconditionally with respect to the statistical sensitive attributes. But then what you have is that the acceptance rate for a loan is 70% for one group and 30% for the other. This what means that you have a demographic parity difference. So you're not behaving the same for the 2 groups. So what one can do to mitigate this effect is to kind of include the sensitive attribute in the model and make this threshold change according to the group. This makes this demographic parity difference 0. So we, as I mentioned, you have many metrics that you can use. So this metric would be lowered to 0, but what happens is that then you're not sure you're doing the right thing. I mean, having a 0 demographic parity, is it helping the certain group, or they are not actually able to afford the loan? So they'll have a problem because you granted a loan, they use the money, they cannot repay the bank. This may cause worse problem to them with respect to haven't granted the loan. So that's not easy to choose the way to mitigate the bias. So another tool that you have before deciding to mitigate a bias is to understand why such decisions have been made. So you want to kind of explain an ML model, a deep learning model that can be a black box through tools of explainability. So I won't go into deep detail, but if you have a simple model that like can extract a linear dependencies from between one input variable to the outcome, it's quite easy to say, okay, you have a low x1, you cannot have the loan, you have a high x2, so you can have it, and this is easy to explain. But when you have non-linear relation, what you may do is kind of go really close to that client that has for loan, or that client that is going to be proposed a new product, and try to say what's going to happen on the surroundings. So what if I go up or down with this x? Will I increase or decrease my y? So this is one example of explainability, a local explanation. But there are also counterfactual explanations. So for example, if I'm here in the loan rejected, what should I do to get my loan? So one kind of explanation can be, okay, so you should reduce your value of x1 and increase your value of x2 maybe, so you could have the loan granted. But this also doesn't work always, because x1 may be the age, and you can increase it, but you cannot decrease it. So it may be, yeah, an explanation, but not actionable. So as we've seen also in some conferences that we attended recently, explainability is also questioning about the coherence that several methods can give one another, and also explainability that must be used by end users, or it should be easy. Sometimes is made too much easy so that you can actually justify almost any decision. So also explaining with explainable methods may lead to be actually not trustworthy. So it's kind of still an open research field, but I guess that colleagues tomorrow will explain a bit more on that. So what we are doing on these topics, we are internally, we are doing working on guidelines. As I mentioned before, we are providing consultancy to the rest of groups. So we're writing down guidelines on how to develop AI, how to measure AI, how to assess it in time, how to monitor it. We are also providing tools that can help in doing so. So if you have several AI models that do the same task, but one is the first release, and then you try to mitigate the bias, you can compare them. So you can be aware of either the bias mitigation action that you made at a good performance, and in terms of business performance, if your mitigation action has decreased the KPIs in terms of efficiency and accuracy of the model. And also we are we're starting up collaboration also in the European Trade Association, and we're trying to participate in conferences and reading papers, and also collaborating with some institutions to produce researches on this field. I don't know what time is it. Okay, so we are working a lot also on accountability, for example. I won't go much into detail of all of that, but accountability is actually absolutely important point, because when you have to answer the client or the regulator about why you made such a decision, the accountability of that decision must be clear. And with the use of AI, it's not always the case. So when we design AI solutions that are delivered inside the bank, we must take into account if that process needs accountability. So maybe the logistics of reloading the cash into ATMs is a process that doesn't need accountability. If I'm wrong in filling an ATM, doesn't matter. But if I don't grant a loan, if I don't explain correctly a product to a client and then buy it and then is not happy about that, this is a process. These are processes that need accountability. So this is absolutely important part of the design of an AI solution. So how you build the pipeline of AI and human in the loop. What we propose when we set up an AI solution is to follow this roadmap to fairness. This is a roadmap that we designed in a collaboration with Fujitsu Laboratories in London. So as I mentioned, there is not one choice that fits all domains. So first, one should design looking at regulatory aspects. then assessing the data sets, the representativeness of groups, the biases that may be included in the data sets, choose metrics, try to mitigate biases, compare different kind of models, and eventually reassess it in the design phase, but also in the production phase. So AI solution, I would say that they are alive, but not in the sense of general AI, obviously. So these are the steps that I mentioned before. So the last step is actually a continuum. You're always monitoring your AI model, your software. And that's why we want actually to increase these collaborations that we already have on explainable AI, to increase the support that we can give to our colleagues in using AI in an aware fashion. These are some of the papers that we published on topic of trustworthy AI. Some are more on the fairness parts. Okay, some are more on the fairness component. Some are more on the explainable AI topic. One recent paper that we published is this one on biases in generated synthetic data, which is kind of a topic that is quite on its hype now. So we found it quite interesting to investigate it. Won't bother you much where we presented our works, but we're trying to spread a bit. In a little video, I may have to play it. Okay, great.
Although algorithms are composed by numbers and code, they are developed by people and learn from data that we decide to provide. Biases that structurally occurs in the real world can easily be replicated or even amplified by artificial intelligence systems. This risk grows significantly in all those cases where models learn from sensitive personal data, social or demographic attributes such as gender or ethnicity, for instance. Therefore, the Data Science and AI Center of Excellence within Intesa Sanpaolo Group has developed a tool for measuring and mitigating biases that can be carried by AI systems. Let us now consider all those circumstances where a model can give a favorable or a negative outcome. In credit lending, for instance, where there is a risk of discriminations toward individuals with respect to their citizenship or gender, for instance. This dashboard can run an assessment on input data that provides fairness metrics able to verify whether the information that we are used to train the model are free from biases. We can also check the distribution on the sensitive attributes to make sure we account for underrepresented groups. Secondly, the tool can scan any pre-trained model and check their fairness level. In this case, we want to check on the citizenship. We consider a standard model where we didn't care about avoiding discrimination, and we compare it with an algorithm specifically designed to reduce discrimination. If we look at demographic parity, the lower the better, we see that input data is around 0.17. A standard model that does not care about satisfying any fairness constraint amplifies the discrimination by some points. However, if we specifically demand for fairness, we can reduce this metric to 0, which means perfect parity. But how this relates to model performances or economical KPIs? Interestingly enough, for this specific use case, If we have a look at precision and recall, we notice that such performance are not affected and do not decrease significantly. Finally, this app provides an overview to compare several machine learning models to pick the best one in terms of fairness and performance. We can select here a series of possible models. Let's pick 3 of them, for instance. We specify which was the non-mitigated model. We specify the sensitive attributes. Let's pick citizenship here. We specify a few other options, and we can see here a comprehensive graph. On the horizontal axis, we have fairness. Again, the lower the better. On the vertical, we have the performance. Here, the higher the better. We are now able to identify and pick
the
the
comparison
that
when
responds to our requirements.
Improve
We are
fairness
constantly
metrics, but you
updating
want
our
also to
methodologies
have
to be free
good
from
performance
biases and
metrics.
make
You
our
don't want
models
to have less
explainable.
accuracy
We
in
believe that those
classification or in
topics are key
forecasting.
features for responsible and trustworthy model development, ready to respond to regulations and to enable a diffuse, efficient, and most importantly, aware use of AI technology.
Okay, this was a brief video, and I want to thank you all for inviting me, and I want also to thank my colleagues that worked on this topic a lot. On the left part, the data scientist, and on the right-hand side, the lawyer and the philosopher that are working on our team. Thank you.
Thank you, Claudia. If I can just throw a question at you just to start the discussion. So you are obviously a big, a major financial center, a major bank as like yours is faced with two contrasting issues, I suppose. So one is, fairness and buonismo, you would call it in Italian. And performance metrics, financial metrics. So I'm not sure I understood what the blend of the two is in your business.
Actually, there are both these components. In the normal life cycle of design and deployment of an AI solution, we work next to our colleagues, like, for example, in the business department. They are the components that is pulling on the side of performances, and we then have to pull on the right from the perspective of fairness. So that's why we're really into it, because first we want to, without blacks, but if we want our colleagues to really be aware of what they're using. Because, for example, now that there's the hype of LLMs, everybody wants to use LLM, but we think that they need to be aware of what they are using. So using it correctly for understanding themselves what they are doing and what they're reading in their answers, and also be fair towards the clients, the end user of the solutions. So these two components, we are on the trustworthy AI part because the others are on the performance part.
Hello. Yeah. So what I found interesting is this bias detection in the data. And I wonder, do you just look at the data, or because what we kind of do recently is to look at the explanations, and based by analysis of the explanations which we can get using different methods, we also learn something about the data, because if we learn that the model is doing something wrong, this can be tracked back to the data. I just wanted to know if you also have looked at this, or is this analysis purely on the data which you present?
It starts on the data sets, obviously, but then when you, maybe I can switch back to the roadmap. This kind of circle let us go back to the business and ask them back what we've done, is it biased or not? So the outcomes, are them biased or not? So we first look at the data themselves, but then in this loop, we kind of learn what the model is doing. So also through explanations, and then going back. But yes, explanation is not the only tool, but is in the loop. Yes.
Thank you.
Sorry, what do you think about the learning from mistakes in this circuit? So Roberto showed us before some robots that fall. As a step in this chain, what is the positioning of what is going wrong after that all seems feasible, and then you start to use it, and then you fail. In a medical framework, we need to show that any drug and therapy, first, does not damage, study phase 1. Second, that provide a benefit in a small group, and then phase 2. And phase 3 is that is in a large scale. So it means that we learn from mistakes. Is there any role in this framework?
Okay, yes, actually, it really depends on the process you're working on, because there are some processes where you get back the feedback and some process where you don't. And also you cannot, but this maybe also happen in the medical field. You don't know what would have happened if you had made a different decision. So there are some processes where you have the feedback, and so you put it back in the loop, and some where you don't have them. And also understanding the feedback is not always obvious. For example, in we have an AI solution to support sales in selling products to corporates. So we are not, and this process is, we don't do it fully automatically. We propose products to salespeople that then go to companies to propose products. We are in the human sense. So if they put back feedback, we can learn from them. If they don't, we can't. And also, if the client doesn't buy the product, he may already have the product from a different bank. So maybe it was a good idea to propose it because they needed it, but they already have. So the feedback of, no, they didn't buy is not enough. I want to know why they did not buy it.
Success analysis. So if you support an AI product in financing and it produce better selling, or people who you approve to loan and they don't give back. So I think that success analysis is a failure analysis in some way. Sorry.
Sure, credits are constantly monitored. So credits, for sure, there's a great feedback there, and it's always in the loop.
Just as a percentage, how much is human in the decisions you make? So in the whole process, you will have a certain portion of machine generated, quote unquote, and human. Eventually, humans will decide, this guy, yes, he has all the metrics, but, or vice versa.
Okay, this is kind of a business topic question, but for credits, there are different kind of loans that you can ask for. And it depends on the amount you're asking for. Also for regulatory reasons, you cannot automatically stop a loan the file, you cannot stop it. So what you can do is to accelerate those where you're sure. So it's kind of a workaround to have some streams of the process that are 100% automatic, and but granting that regulatory aspects are attended.
Thank you very much for your talk. Can you give us an example like this police violence in the US? They had this profiling, and they found out that some district, if the police stops out of the profiling, certain people, they do really a form of police violence. Is there a form of bank violence, which has been demonstrated by using, let's say, complex statistic tool, that you don't give a fiduciation, I don't know, a credit to some people that actually would be, if you look really carefully, would really have given back all the debit, but based on this model, you generate the bias into the system, because you want to be fair, and it would be great to give an example of bank unfairness, which is based on data, like police people say this Floyd case of the white supremacist police violence was brought as a flag, as an example. Is there something like bank violence from this point of view out of your data? Go there, you double check people because the printer is very fast. And this might bring to a certain bias, some police violence. Is there an example of bank violence based on not really carefully treating the data?
The correct answer is no. No, just a joke. No. Actually, the financial sector is really full of regulation. So these things cannot happen in an aware fashion. We're not aware of such condition. What I was talking about before, also in insurance files, for example, or loan files, what you can do with data is accelerate the granting of loans or insurance that you're sure about, but you cannot stop files that just because of like few features.
Yeah.
Actually, I would like to come back to Vincenzo's questions, the relationship between your team and the performance team, because in the end, that's actually the connection is the interesting part, So can you put actually a price tag to fairness? How much is fairness worth in your business? The price of fairness. The price of fairness, of course, that's in the end the question, If you want to be fair, what does it cost? And is this then, from, let's say, a societal reason, is this something you want to put on the whole society, for example? This is what we do in our health system. In Germany, for example, for a long time, women paid more than men for health insurance because of giving birth being a higher risk and so on, especially younger women. And then at a certain point, the constitutional court said, no, that's not fair. And they changed it. And there is, of course, a price tag to it because it's getting more expensive overall. So I wonder, do you have such a model?
Actually, we cannot really measure it, but we always have to assess if there is a fairness topic in that process. So you have some colleagues coming from the people that work in the corporate environment, they don't have fairness problems because they are not working directly with people, with end consumers. So where fairness comes at, it's when you're talking about credit loans, when you're talking about risk measurements, and the business areas are more concerned about performances, while the governance areas, for example, risk, is not concerned about performances.
Yeah, but you know, if you would have a price tag, then you could tell people it's a little bit like, you know, taking the plane and then offloading your CO2, for example. You could tell people, you know, we are actually going back actually to the loans. Now, I think this is a pretty clear example, you know, where you have, if you give loan only to people who are super credible, then the probability of foul loans, you know, are highly decreased. I think you can put a price tag to that. You should be able to model how much you lose if you start to include people from the other group, and you could basically socialize the loss somehow, you know. So that, I think should be possible somehow.
Actually, it's not quite a decision for the bank, for the business area. Is actually we have to assess the fairness topic, because either you can choose how much be fair or not, either you cannot choose, because it's really a high regulated field, the one of the financial sector, the insurance sector, as you were mentioning, also in Germany about these prices for different for genders. So in some processes you cannot choose where to put the balance. Mostly you have to assess if you have to choose fairness at all, or you can put the acceleration of performance. But also when you assess fairness, then you come to choose the right fairness metrics. So it's also is not 0-1 anymore. It's you have to choose the right metrics, and there maybe you can have some little tools to balance the two components.
I think we have to be fair to the chef and move to the dining room. Thank you everybody for this very interesting morning.